Well, hello, listeners, and welcome back to Manwatch Required, the inspection podcast, where our mission is to share knowledge and attempt to entertain you at the same time. On today's episode, we're going to talk innovation, new technologies, and maybe even a bit on drones. And because you've been so good, we brought in another special guest. Enjoy.
Scott, we have a real guest in the studio. One we didn't rope in, hey?
Yeah, we didn't have to make this one feel bad and came in under his own will, so that's nice. Something new.
Something new and a pretty interesting topic. I know the last time we kind of issued an episode on this was around Christmas time, and it was about inspection technologies and stuff to assist with remote visual inspections.
Yeah, and then I think with talking with our guest earlier, I believe it was our COVID episode or something to the degree of new technology that kind of sparked his interest. But we'll let Warren elaborate on that. Maybe without further ado, we'll let Warren introduce himself and maybe what his position is, who he works for, what he does, that type of thing. Whatever you're comfortable sharing with us.
Sounds good. Yeah, thank you for having me on the show. It's a great privilege, and yeah, it was your pandemic episode that really caught my attention. I've been at Maverick Inspection. I had to look to make sure, but October last year, it's as of then it was 25 years. First time I show up in the book. So
oh wow,
yeah, it's been quite a while. I was I'd say I was the first technician outside of the standard NDT work that we did. So my current title is executive director, and I'm also the R&D team lead. So how I started at Maverick is during school, I worked in the pipeline. I had a QO and I was on the repair crew. So going across the prairies, throwing the X-ray tube on the pipe, strapping it on there with the film. And it was pretty fun, kind of like John Wayne for a while. And
nice.
That's where I met Phil Bedard. He was doing UT on the repairs as well. So he was a pretty awesome guy. So from there, we just started talking, and one thing led to another. And so then I started with Phil. He was doing the standard non-destructive testing. So his background came from the military, working on the jets in the Canadian military. So I think they called it the F5 Freedom Fighter, CF5. And so that was his background. And when he went into non-destructive testing, he's working for some of the bigger companies doing the standard non-destructive testing.
Yep.
But his interest was always the weird and wonderful stuff, especially the video inspection. So as soon as he opened up his own shop, he bought a video probe. Mm-hmm. And then my job early on was to be the video inspection guy. So I ran into him, he brought me on, and so I just went out with that piece of equipment first. And one thing led to another, and video probe to our first robotic crawler, to our first push system. And that was early days. I mean, back then, I don't think anybody knew what RVI was. There was no term RVI as far as we knew. No. We just called it video inspection. We're just like, I don't know, camera inspection. Most people on site, you could show up with a crawler, even now, like a fancy crawler, all the bells and whistles, and they say, well, you're going to boroscope.
Yeah.
So we were just a boroscope guys, right?
That's the generic term, yeah.
Yeah, exactly. So, and then from early days, it was straight into R&D, because the remote visual inspection tools that we're used to seeing weren't developed initially for industry, like for industrial applications. So you think of a video probe, that would have come from medical endoscopy originally, right?
Sure.
Like that's like, you get your colonoscopy, or you get, a video camera going into your arteries or something. Well, that's kind of where that started. Yeah. So you get an industrial version, and it's just kind of an industrialized version of the same sort of thing. And then you go out on a site and you're like, well, okay, I have to look at a shell side of an exchanger. I have to look at this. I have to look at that. So how do you do it? There's no procedure, there's no set method for doing it, and sometimes you have to build a jig or a different way of getting in and seeing what you're doing. So R&D was right there, right from the get-go. Mm-hmm. Our first robotic crawler was a track system from Inuktitut, a Canadian manufacturer, and the camera system, the pan-tilt camera, was made by a company down in the States called VIT, and that's the lineage now. I think EnviroSight is the same kind of brand now. All married up together with a custom controller for it. So you can imagine, you have this crawler system you can configure in different ways, but you run into scenarios where you can't get the crawler to where it has to be unless you do significant changes in the field or on the fly. So a good example was the power generating stations. You're looking at, say, a steam header, and you have a 3 3/8 inch handhole. Well, your crawler doesn't fit through a 3 3/8 inch handhole.
No.
All the pieces do, And if I really squish my hand, kind of like you kind of get out of handcuffs or something, I can get my hand in a 3 3/8 handhold. We actually drilled a hole in practice before we did the job.
Okay.
So Phil and I'd sit down, he'd be like, okay, well, I think we can do this, but we had to take all of the screws out and replace them with studs, put wing nuts on them, and have it so one piece at a time, you fit through the handhole and then put it all together and screw it together to inspect the steam header.
Interesting.
So a couple nights before, I'd sit at the table and put the crawler on there and close my eyes and be like, okay, it's kind of like training for a heist or something in a movie, right? You're like putting it all together and doing the thing. You're like, okay, I got this down. So then you get to site and you get all ready to go and you go on a tour with the client to what your work's going to be. And there's the steam header and the handholds on the bottom and the scaffolds above it. Yeah. You're like, well, it's a good thing I practiced because now I'm hanging upside down wearing a respirator doing this. So,
yeah, blindfold.
No, it worked. Wow. So yeah, that's been, from the very first job almost, the R&D aspect was a big part of it because, like I say, these are tools adapted from outside of industrial applications and brought in. And same with the push camera. Like push cameras were traditionally a plumbing tool or that type of inspection tool. And to have them adapted for industrial uses, you can do it, but you also have to be able to adapt and be able to get access to the money shot for whatever you're trying to do. So early days. And then from there we branched out. So we got into the infrared thermography. In the early to mid 2000s, we were the FLIR sales representative. So we did sales, we did rentals, we did training, put on the courses, level 1, level 2. And so I got a lot of exposure to the infrared side as well. Going out for FLIR's clients, if they were interested and they had a special application, they wanted to figure out how to troubleshoot something or adapt it or set up a program. So I was able to be involved in that side of it. And then we picked up our first ground penetrating radar system probably in about 2004, 2005. Started scanning concrete with it, and then that just kind of snowballed and gained traction. We got more and more systems, different wavelengths, different applications, brought in more people with specialized knowledge, started to bring in more and more technologies, and just kind of goes from there. So
what would you be scanning the concrete for? Just breaks and cracks and stuff in it, or?
No, specifically the biggest application we used it for early on was before you cut or core in concrete, making sure you don't hit any conduits. If you want to miss structural steel. So what they used to do is they used to use X-ray for it, of course. But you can imagine taking X-ray and you have a thick concrete slab and you have to clear a huge area. You're downtown in a high rise or something. You have to clear a huge area. You have to put your film on the bottom, your source on the top, do a long exposure, and then you have to go mark everything back based on the film, deal with parallax, deal with everything. It was done for a long time, very ponderous, very expensive, very difficult. Then radar comes out. Yeah. You don't get the picture, but you get real-time results that you can verify, you can go back and forth, and you can map things out. So it very much revolutionized that side of things. But as far as the other applications with looking for other data related to concrete analysis, that's a whole nother aspect, and that's more on the engineering side. And we gather data now related to that for engineers, but that's not the sole purpose for what we do for the most part. So.
Yeah, wow, that's quite the change. Like when you talk about time consuming, going from doing a RT shot and something that thick with that exposure time, and then just the safety factor, right? You can't have anybody there. Yeah, and then ultimately that reflect on the cost too. So that's totally revolutionary, like you said. Wow,
it's one of those things too. We talk about the adoption of technologies and the resistance and how it changes. People were very used to using X-ray for that, so they would write into their procedures, or the methods must be X-rayed before you do it. Yeah. And for a long time, they'd still refer to what we did as X-ray, even though we weren't using X-rays. Yeah. And sometimes you run into engineers or different groups who would say, no, it must be X-rayed. Yeah. And you'd say, okay, and this is even not that many years ago. Sure, that might be the right thing to do, or you might, whatever. You go find somebody who's going to do that downtown Edmonton for you. And it's great, but if you don't, give us a call again, and we'll pursue it other ways. So,
That's an interesting example. Like kind of for something related to our field with like construction. If you want to look at that, it's kind of like the phased array versus the X-ray, and there's a lot of that attitude too. Maybe not so much anymore, but I know like years ago there was where it was X-ray was the only thing that was trusted, and I think a big part of that was there's a picture. You can look at it and you can see, okay, that doesn't look good, or that looks good. Yeah. Whereas the phased array aspect, it's like, well, this guy said it's good, so it's good. Yeah. So there's a little bit of that mistrust there, I suppose, but kind of related, I guess, in some degree.
Oh, absolutely. Yeah. And with a lot of those technologies, like it's not like X-ray is obsolete by any stretch. Like it hasn't really changed substantively since World War II, probably but it's still very, very valuable, and it's the right tool for the job in a lot of ways. So, absolutely, yeah.
Yeah, a lot of times it is, right? And it still gives you that nice picture, which is it. In some cases, it's hard to beat that.
Oh, for sure, for sure.
Yeah. So I guess we're going to dive into our whiteboard here and kind of start following what we got. Not that we've been off topic, but so we have kind of just different little things, and Warren's alluded to just some personal uses and current technologies that he's used. It seems like from what I've seen, and maybe Scott or Warren, you can elaborate, like for the visual side of things haven't really progressed from, decades. It's mainly just been a camera on a crawler or something like that.
Yeah, no,
and now it seems to be like, even like you said, these were all outside technologies kind of adapted to use in industrial situations. And now it seems like they're starting to custom make things for certain applications, right? I know personally, the most I've used is maybe a crawler with a camera on it, or even the usual rigid borescope, or if we're lucky, we get a fancy GE one that hardly seems to work most of the time, right? Scott, have you used anything else besides like borescopes or anything like that?
Not really myself, no. Just the borescopes, or like you said, the fancy ones where you can control the camera and kind of look all around, which those are nice. They work great too, until they get hung up on something, obviously. But
I've destroyed those. I once got one stuck in a ring gear in a big coal mine around the teeth, and the only way they could get it out was by starting it up. It didn't fare very well. So, early years, I was learning. Yeah.
You got to do those things to figure out what not to do next time, right?
That's the R&D part as well, right?
There you go.
I think I also mentioned in the last episode, I think around Christmas with Cortland there, I did have an opportunity to work with an ROV, submersible ROV, right? That was pretty neat, but I think that's where you kind of picked up where I was extremely resistant on even wanting to use it, right?
Yeah.
And
I'm surprised you found an application where you weren't stirring up so much silt in the water that you couldn't see anything, because most, like when you're in the prairies and you're landlocked, most things you put it in have enough silt and enough materials that the props stir it up so much it's really hard to see. So we found very few ROV applications. A lot of them are maritime where you're looking at ships and such where the water's clear. So that was really great that you found an application where it worked for you.
Well, it was actually a D-min water tank.
Okay,
so it was pristine in there. Like the biggest thing we had to worry about was making sure it didn't get sucked into the outlet nozzle with the pump on it, right? So other than that.
I don't think your operator would be too happy if he did that.
No.
Well, he was driving it. I was just there to watch and report, because all he did was they flew him in from Texas actually to just drive this thing, and it was a maritime thing. They were used to doing offshore platforms and stuff like that, right? So,
I imagine that's a big industry for that. I mean, because what's the alternative? You're going to gear up and go down there yourself,
Well, I guess at certain depths you could only go so far with a human, right?
Yeah.
Before it starts getting really expensive.
I remember back in the day, I don't know how long, but I remember listening to an interview with, I think his name is Robert Ballard. He was the guy that discovered the Titanic.
Okay.
And he was talking about back in the day, they would go into an actual underwater craft, and he'd be an operator and a passenger in it, and they'd go all the way down and they'd look at something. And then when they were looking for the Titanic, he had an ROV, and he's sitting up in the ship, probably got his coffee, and it's all nice, and he's looking through the ROV at the seabed and doing his search. And what he realized is that there wasn't a big difference, because whether you're inside the vessel or you're using something remotely operated to do the same thing, you're seeing the same information.
Yeah.
And your consciousness is where the tool is at that point, regardless where your body is. And he was talking about, like, this is earlier days of the internet, how his son would play video games and have friends halfway around the world. And it was so exciting because in the same way, his consciousness was halfway around the world, regardless where he was sitting. So I remember that very much, thinking about that, because I was doing the remote inspection and thinking the same thing. It's like, when you're driving down a pipe and you're 300 feet down a pipe, your consciousness is where the camera is. That's
a really interesting way to put it, actually.
Yeah. Good perspective on that.
And I was going to say, James Cameron didn't find the Titanic there.
Well, and then the funny thing about the story, of course, is, and everybody probably knows this now, is they weren't actually looking for the Titanic. They said they were, but it was a military operation looking for something else. The Titanic was their cover, and then when they found the Titanic, they're like, oh, now what do we do? We actually found it.
The cover story came to truth,
Wow, that's pretty interesting. Oh, cool. So, okay. Other than borescopes and stuff like that, nothing really jumps out to us right off the bat. I know just, again, from kind of my personal perspective, it seems like the technology has kind of been pushed towards the UT side of it, right? There's been huge advances in the NDE side of it, but the visual side, we're still relying on guys like Scott and I to jump in and poke around a little bit. And sometimes that's not possible. And we do have to use less than desirable tools, like not to knock rigid borescopes or something like that, but they're fairly limited. And even the picture quality, right? Or as soon as you get a little bit of dirt or something on it, you got to pull that out and clean it. Or the example, like we were saying, using a shell and tube exchanger, like trying to figure out how to snake that in and try and actually look at something of value aside from, there's the top of the tubes and a baffle, or you know what I mean? So what ways or is there anything new that you're talking about using jigs and stuff, but is there anything else that you might be able to use in, say, for example, a shell and tube exchanger or something that might help get around obstacles within equipment?
You're still limited by a lot of the same things. I think what really helps is having more tools in your toolbox. If you have one video probe of one specific diameter, length, capability, and you try to do every job with it, you're going to do them all to some extent, and you're probably going to wreck it. And the like the really fancy video probes you guys are talking about, like you can get the ones that you can do point cloud measurements on. You can get very precise.
Oh yeah.
Oh wow.
But at that point, you're probably very specialized yourself. You're someone who's looking at, say, turbine blades and the gap between the shroud and the blade or something. You're measuring very precisely. That is a very precise tool, and you're going to use it for that tool, but you're not going to take that same video probe and give it to someone doing tube cleaning and say, here, check the quality, the cleaning procedure and see the effectiveness of it. Because something like that, like you smack it against something, you step on the grating, and you basically have $100,000 piece of spaghetti, like it's done, right? So, and that's been one of the limitations too, is there have been very specific tools built for industrial purposes, but they're also built for very specific purposes, very narrow range of applications. The thing that has really changed, I would say, in the last 5 years or so, and the Helios platform, the UAV platform, collision tolerant drone, has been the big game changer that I've seen, because it is the first multi-purpose platform and tool built specifically for industrial inspections, but built for basically any type of industrial inspection you can fit it into. So it's not limited the same way. And I think that's one of the things why for the visual inspection side, you guys have seen a big change, is because we have all sorts of, fancy robotic crawlers and drop camera heads and things. But you get a large size vessel, if you don't want to break that plane, how do you get it to see close up all the areas? So I can get you to one area or another area, and I can look at specific things you want to see, which is why the video inspection or the RBI has been used a lot for say reactive type inspections or targeted type inspections. But now you get something that is basically like a little dandelion fluff ball floating around, and you can actually do the entirety of the inside of a larger vessel. It changes everything, because that's opened up all sorts of opportunities for using it differently. And even like you guys, when you're talking to Court before, towers. We just did a tower. It was a 24-inch access, 30-inch diameter. It had trays with bubble caps. They knew that they had some bubble caps missing, found them in the bottom.
I was just going to ask, was it a trade tower? Because I'd be interested to hear how that went.
It worked brilliantly.
Really?
Yeah, we were happy. The client was happy. It worked awesome. But again, it's in the past, you would have been taking, say, a camera on a pole, put it in. It probably would have got you the same information in that particular situation.
Sure.
But you get something much bigger and more complicated internals, and that's where you have to have something that's more agile and can move around, and so.
Well, and then you can really, decide if somebody needs to go in there or not after the fact, and if they do, it's a lot more pinpointed too, right?
Exactly.
Because you can go in there and see that there's nothing wrong, so that eliminates a person actually physically having to go in there entirely, right?
Oh, exactly. Well, that's what got me so excited when you guys did the pandemic podcast, because I showed Scott earlier. I actually brought my notes with me. I was taking when I stopped a half hour through, started taking notes. I'm like, this is so amazing, because there's always that, how do you use the technology, and then the vision for it, and the idea that you can fly the Helios inside of a larger vessel of some sort. You can do your inspection, and then you can decide, okay, based on that, we know that overall we're satisfied with the inspection, except for here, 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 and here. We want to take a closer look. Somebody needs to go in there, get a scraper, a light, and actually take a look at what this is. Well, then you only have to build scaffolding to get access to those specific parts. So suddenly your cost, your efficiency, your safety, everything is improved. And so I wouldn't say, and this is something we can get into, but I wouldn't say we're at the point where it replaces visual inspectors entirely. But it's just another tool, like you guys say, in your toolbox. And the technology is changing very rapidly now. Like the reason why we have the Elios 2 now, it's a combination of processing power. It's a combination of just the willingness of people to develop new solutions. And they not only built it specifically for industrial applications, they marketed it very well for that purpose. And that's the other thing. When you have companies that produce tools, and they produce a line of tools from their tools that can be used for industrial applications. That's not the focus of their marketing. They don't educate. They don't have all the training and everything in place. Flyability has been very good as well about training the clients on the applications, on how to use it. So that's been part of the drive to really move things forwards. But this isn't just something that's happening in the inspection industry. If you look around the world, the increase of technology, the rise of technology and development of it is nonlinear. It's been accelerating as we go. I know that economists, a lot of historians talk about the fourth industrial revolution, or the fourth phase of the first one. And it's the point at which the automation is happening. The machines are becoming, developing much and much faster. And that's where you get the notion of the disruptive technologies. Technologies develop quickly enough that they make things before them obsolete or disrupt how things were done. So I don't think the Elios platform is at that level yet, but it shows us where we're heading, right?
Sure, yeah.
Yeah, so it's definitely.
With the, can you program the Elios for that? So like, say you go in that trade tower, can you take data points on that, on its flight path, and then repeat that again X number of years later if you still have that information?
Yeah, exactly. So you can follow the same flight path.
Wow.
Yeah.
And how resistant is it to getting hung up on those trays and that? Can you crash in there pretty good with that thing, or do you got to be pretty precise with the controls?
You want to be careful. I mean, just because collision tolerant doesn't mean
Right.
it doesn't give you just like a license to do whatever you want. But from our perspective, and that's where the pilot has to really know what they're doing. You go in first and you do a kind of pre-flight. You look around, you see what you're getting into before you do the inspection. You look at drawings before you do it. You discuss it with your inspector and your client. A large part of the workflow is the pre-flight work, like getting it all prepared, everything from, making sure the pilot has the right certifications and training to the airspace you're in, especially if you're outside of a vessel or something like that. Sure. And then all of your emergency response planning, the whole thing leading up to that point makes it so you don't do those kind of things. Because I mean, it's a very expensive little dandelion flop as well. So from our perspective, we don't want to get it caught up on something. So yeah. I
guess it's good talking with the inspector that's been in there too, because I mean, it's the things you catch your coveralls on is probably the same thing that's going to hang up the cage on your drone too, right? So
100%.
Good things to pre-plan for,
Yeah. And then once you've been on a site for a while and you've actually gone through the same vessel, you get to know, and then you can, then you can maybe push the boundaries a little more. But you got to be pretty careful with it. But that's with anything you do, right? Like the same level of diligence across the board should be that level of diligence. So just because you got something that's collision tolerant and fun to fly doesn't mean you can use givers. So.
Shouldn't be just crashing it into things.
Exactly.
I think tolerant is the key word there,
that's
right?
right?
Yeah,
that's
it's
right.
tolerant. So that's pretty neat. Now for your pilot certifications on those, I guess obviously, what is it? I think it was the Nav Canada stuff applies, right? What else would is it Nav Canada or the aviation, whatever certification we got?
I'm sure Warren knows more about this, but I was going to actually steer that direction too. And you mentioned if you're inspecting inside a drone versus outside and the differences there, that might be something informative we could talk on too, or we could listen to you talk on.
Well, and again, I have the pilot for that, and they do that side of it as well. But so if you're going to be in different airspaces, different requirements, different permissions apply, and that's part of the training the pilot has to have as well, to know what they're doing, what they're getting into.
Kind of like flying a plane, I guess, right? You got to know where you're flying.
Oh, exactly. And that's the way we look at the operation of the unmanned aircraft. Is you're still operating an aircraft, you're operating a vehicle.
Yeah,
so
your
focus is on the planning of the trip, the safe operation of it, the maintenance of it, making sure everything's in good condition. What do you do if something goes wrong? It's just like anything else with a vehicle or any other sort of. But the one thing with the drones I find is that because you're doing an inspection as well, you have to be careful that you're focused on the flying and not just focused on the inspection. And that's one of the things you find anytime you get that tunnel vision. Like if you're doing infrared, you're walking around a roof with an infrared camera, you're looking through the camera. You don't want to step backwards and trip over something, or, it's the same sort of thing. You have to be very cautious. So that is one thing that if we were going to look at the roles of the pilot and the roles of the inspector, at least from my perspective, ideally, I would look at those as being two different roles. Because like you say, there's a level of skill and qualification and planning and a lot of detail you have to look into when you're operating the drone. So like I say, everything from pre-flight planning to the safe operation of the drone, all the emergency procedures. When you're doing a visual inspection, your focus should be the visual inspection and making sure that your diligence is applied there. If you're trying to do both simultaneously, I think at least right now with the technology the way it is, you'd want to be careful that you're not, lowering your quality on both of them simultaneously. So.
Right. Yeah. I was going to actually ask that if this is something that works better as a team. Do you have people that are multi-certified that try to do both? Is that just not a good idea generally? It's
not the approach we've taken, and partially because we work in so many different industries. So we don't just work on the industrial sites doing visual inspection. Like the applications and the diversification that we're into, like we could take our Elios drone, we might do something, it's commonly used in, say, we don't do mining, but underground mining applications, you can use it for building applications. There's many different things you do. Even like back in the past when I would do infrared, I wouldn't just do electrical scans. I wouldn't just do building science. Sometimes I'd be flying around in an aircraft doing wildlife surveys with it. If you're a technician and you're an expert with the equipment, you hit so many different applications that to be an expert in all those applications is very difficult. So that's where, from my perspective at least, and what Maverick looks at is that our pilots would work with people such as yourselves. You're the inspectors. You'd pre-plan what you're going to do, and you'd be working with them doing the inspection portion while the pilot has the hands on the controls. And then you can direct what's happening, but you can also be paying attention, taking notes. And we can discuss a bit more about what I think, a good workflow would be and how you can really get it efficient. But that's where I see the separation between the two at this point with the technology, how it is still being quite important. So.
The Elios, does that have separate controls for the camera, or like can the inspector control the camera, or is the pilot controlling both?
I think if you have two controllers, you could separate it out between the two. Yeah. And that's with most of the cameras, you can control the different systems if you have two controllers put together. So,
I know with the larger drones, you can have a two-man team, like especially for like film industry and stuff like that, where just like you said, one guy's flying and the other guy's running the camera, right? So with the inspections, it might be something like that, especially if, inspector eyes always wander, it's just even walking to and from the trailer, you're always like, hey, what's that?
Oh, exactly.
You go poke around something else that you should have no business in. Huh?
Or the other model would be, and this is all being sorted out because this is early days, right? But the other model could be you have two controllers and the inspector could be controlling the drone and doing the inspection, but have the pilot with another controller just in case.
Sure.
In case something happens, you have that other controller, because if you aren't focusing on what you need to be focusing on to fly the thing, and something, so you do see that thing, you catch your coveralls on, you want to be like, okay, watch out, So.
It's kind of like the driver training car with the extra set of brakes on it. If you they can override you if they need to.
And where I see it going, and we're already there that we could do it, but whether industry wants to get to this point or not is, let's do a thought experiment. Imagine you guys talk to my pilot before a turnaround. You say, I have this vessel we're going to inspect. You plan how you're going to inspect it. You get ready to go. And on the day of the inspection, he does all of the pre-flight planning, everything to get ready to do the inspection. You're sitting in your office or you're sitting at home in front of your computer and you watch the inspection and direct it from there. You take your notes. In between vessels, you compile those notes, put it together, and you basically have what needs to be inspected manually, and that workflow ready to go, where you need the scaffolds and where you need to put them. And he's already moving to the next vessel, getting his permits in place, getting his drone set up, making sure everything's ready to go. Does the next one, you're involved in the inspection remotely, you take all your notes, you get ready, and as he's jumping from vessel to vessel, you're wrapping up what you just did, and at the end of the day, you could have however many vessels, and you already know your next step in the workflow. And that's where I see things going with the current level of technology.
That sounds really efficient and almost too efficient, but it sounds it sounds kind of like it sounds pretty neat. And most likely, I think that's where stuff might go, or it might eliminate Scott and I as contract guys out of the equation altogether. And you can just have your resident inspectors sitting at their desk right in the office, monitoring all that stuff, while they have just a bunch of robots and technicians out in the field operating this equipment. Yeah, you know what I mean?
Yeah, and I can see it. Like it's a very real idea. There's no reason that it can't go that way. How does the video streaming work? Like, is it efficient? Is that technology good now? Like,
it is pretty good. You can see like with the zoom and everything else how it's getting. It's pretty good.
So if you're sending it up to a TV or a computer screen, somebody across site or whatever,
If you have Wi-Fi, it's a lot better, and you save a lot of money on data, of course. But it can be done otherwise. So maybe one day we'll set up a demo and get one of you guys. We find a little vessel somewhere.
Oh, that'd be amazing.
Yeah, find a fabrication shop or something. And that'd be awesome.
That actually, when we were talking about just kind of like the certifications and stuff like that for your training of your pilots, do you guys have like a practice vessel or something like that? Or do you kind of, when you're at a client's facility, say, kind of test, hey, do you mind that trade column? We've never done something like that before. Like, do you mind if we chuck the Elios in there before a guy goes in and crawls through it?
Well, nowadays on sites, I mean, it's really hard to step outside of the scope they brought you on for, because there's so much,
fair enough. Yeah.
I's to dot and T's to cross. But we do have, so if we know we're going to do a job of some sort, just like I would practice before putting together the crawler, kind of blindfolded. If we know there's something we're going to do that we haven't done before, I can make mock-ups in our warehouse space of some sort with the idea of the size and space, and get the guys to fly through it and do a bit of an inspection. And same with, and that's, for instance, I built a refractory sample that's kind of a curved wall that's about 4 feet by 8 feet. And it's got some, problems where refractory is missing and stuff. It's all theater. It's not true refractory because it's nice and light and hangs on the wall. But then they can fly it. They can practice going back and forth. And more importantly, they can learn how to fly it in a way that they can gather data, that they can make a point cloud, and they can do photogrammetry from and give an actual model off of. Because how you fly it in every different situation really has a large part to do with the quality of the data and what sort of model you can build. So I'll build them sample scenarios. So I say, okay, you're going to be going and doing this job, I know, and this is what you have to do out of it. So let's build a sample, and you guys practice for a while and get your skills up. Because again, it's one of those things where you go in front of the client. You don't want to be like, hey, it's my first day in the job. I'm going to see what I can do with this and see how I can do it. Yeah. There's always scenarios that you can't account for, and you do have to, do in real time and think on the fly. But if it's something we know that we can test ahead of time, and especially, and this goes back to the R&D side, if you're building a new way of doing something and you're going to take it out on site, you don't want to test it for the first time on site. So we have a laser profiler system that goes on our crawlers, and it puts a ring of light around a pipe, and then it can, off the video, it can measure things like ovality and such. And it's a pretty decent tool. And let's say it's built for a certain pipe size, and the client says, well, can you do a 48-inch pipe? And we're like, well, we've never done a 48-inch pipe, but let's find out. So we made up a skid that we could pull it with the crawler instead, that gets it bigger, gets it taller, centers it, and then we mocked up a 48-inch pipe out of what material we had in the shop, made it, however long, and tested it out. I was like, yeah, we can do a 48-inch pipe. Or we had a client that had a underground line that was, mostly full of water, a larger line, probably 2/3 full of water. The crawler is not going to do you much good. You don't want to, even with a scissor on it, you don't know what's underground or whatever. So we built up a raft for it, an articulating raft you can fit down through the manhole. And it took a little bit of R&D, because when you get into buoyancy and water and controlling, make sure it stays upright and go around corners, and, different camera systems so you can adjust it so the buoyancy is right and the angle's right and it stays flat and everything. So again, we filled something with water and tried it out and, play with it and get it.
And that was successful?
Oh, it's brilliant. Yeah, it worked awesome.
What drove it? Like the wheels still, or did you have to put some sort of prop on it?
Just the water. So the water's flowing through the pipe. So you have a rope in the back, and you just hold onto the tether and just let it out as fast as you want. And then pull it back
so you control it with the rope, essentially.
Yeah. And there's commercially available rafts for a lot of these systems from various manufacturers, but you look at them, you look at the raft, and you're like, you look at the price.
Yeah.
It's not that I'm not willing to buy it if it was good, but you look at the price, you look at the raft, and you're like, it doesn't look like I'm spending that much on it, and it doesn't work that well. So I can build something better. So the only thing is that, it takes a bit of time to put a solution like that together, and, it takes a little bit of money, but it's not that expensive. Often our clients, especially the bigger clients, you tell them your R&D budget, they kind of blink and they say, shouldn't you add a 0 or 2 in the end? You're like, no, give me a couple weeks and just to cover our costs and the material. It's all good. It's all good.
Yeah.
So, yeah. Well, on the other side too, we'll keep using it for other jobs, right?
Sure,
so it's not like it's not like it's just lost. So.
Wow, that sounds like an ideal job though. Like you're not only finding solutions for problems, but like you're having a lot of fun doing it, right? And getting to play with high tech toys, kind of figuring it out. So actually, Scott, you brought up a point is like, I was thinking, especially that underground stuff, I was going to think like, how do you guys control it? But if it's tethered, I guess that makes a lot of sense.
It is hard going to things like the Elios drone, especially the price tag on it and not having a tether. Like some jobs you might tie a string to it or something to, make sure like Court was saying, but in my mind, I'm just so used to having a way to get it back out of whatever you're putting it into, like a crawler. Like I've had crawlers go into things before, when I was younger and such, had them flip over, had them get kind of wrapped around themselves and stuck, and you got to pull them back out or find a way to get them out. And having that tether sure makes you feel comfortable. So it's
in that situation,
it is a bit of a leap of faith when I see our pilots fly off with the drone. And I'm kind of like, that's a lot of money flying there. And whenever it comes back, you're like, that's awesome.
Yeah. It's a kind of a sigh of relief and it comes back.
That's right. I think for like a big tank or a sphere or something like that, unless you go in through the top, you're going to just fish it out of the bottom, but like in a trade column or something. Yeah.
Or underground piping of some
underground,
sort. Especially if there's anything on the bottom, that if it gets into, it's not flying out. If you're like, so yeah.
Oh, that trade column, I don't think anything would do you any good in that. If you got hung up halfway through some trays, like you're not pulling that out with the tether, are you? No way.
You got to wiggle those joysticks, Scott, and just kind of get it free.
Go in there with another one and knock it loose.
Well, and a lot of times when you get into columns and stuff too, if you have access ports, you use a smaller system. You go tray by tray. And you look in and look around each area and look around each area. Right? So like back in the day, I did lots and lots of the glycol D-high towers out on remote sites. Do the infrared from the outside, run it with different operating kind of parameters because they have a problem with their dew point, and you can look at it and see where the glycol's hanging up, see where the fouling is, see how it's running. And then if you want more information, you start pulling out the inspection ports and putting a video probe tray by tray and looking and hoping that they don't have a bubble cap like right in front of each inspection port, 2 inches in or something. So
usually they're the older style design, or they're like this, like 6 inches tall, right? That's actually pretty interesting, and I think that would pretty much work because like a lot of the wellhead facilities and stuff like that, they're narrow towers that are uninsulated, right? And so
work great. It was fantastic. Absolutely. And you, after a while, you do enough of them and you just basically know almost when they tell you what the symptoms are, you're like, I'll look at it with the camera, but I'm pretty sure your problem's going to be this because you see enough of them. It's like, it's always the same, right? So
that's pretty neat.
The usual suspects. So,
So aside from the Elios, does Maverick have any other drones or have any larger?
Quite a few. We just picked up the M300, so the Elios platform, they designed it opposite of all of the drones. They said, we're not going to go with sensors for collision avoidance. Instead, we're going to make it designed to bump into things. Their kind of metaphor or an inspiration is like a fly. You're trying to whack it with a fly swatter. It's bouncing out the window. It never gets hurt, bouncing off the screen door and the walls and stuff. And that's kind of how they made it, nice and light and
good way of putting it. It is
light
like a
and
flyer.
agile and can go around. Whereas like the M300 is exactly the opposite. It's the Swiss Army knife of drones. So as a UAV, it has a great many proximity sensors and positional sensors, very accurate, and it's allowed to maneuver through spaces because it's aware of its surroundings. And then it's built to be a multi-payload. It's not not one of the really big drones to carry heavy payloads, but overall it's built to be a multi-payload for the infrared, the visual, and things like LiDAR and such.
Yeah, like multi-camera systems and stuff like that, right? Yeah. That's pretty good. And I think before we talked, you guys said you guys had a project going on with the M300s, or was that something different?
We've got a few projects going on. We use it quite a lot in conjunction with the other services we do. So if we're going to do, say, a very large utility locate, and we're doing all the markings, and then we put together the deliverables in the drawing format so they can see and put into their CAD programs or whatever they have for their users. If we put the drone in the air, we can do the photo mosaics and put together real-time imagery of what it looked like at the time that we did the subsurface investigations. So if you use something like ground penetrating radar, it's very nice to know there was a puddle there and a car parked there, and here's where the manhole cover was exactly, because then in real time you know exactly what the ground was when you did it, and it makes very nice sharp imagery and a much better deliverable. So
yeah, Yeah. Well, I can see the puddles maybe depending on the surface for settling and stuff like that.
Exactly.
Right?
Exactly. And there's lots of times when you get up in the air and you look at something, there's a world of subsurface data, even with the remote sensing from the air. So for instance, just a little bit of an aside, but I had a house that was in Edmonton in an area where there used to be an old lake in a park right very close to us. And our house, after the flood of 2004, we had water coming up in the basement quite a bit. And, the front was starting to settle a bit. Like, what's going on? So I said, there's got to be some aerial photography or something, because I was used to looking at satellite imagery for other purposes like this, right? And so I found old 1930s aerial photography, the old stereoscopic type black and white.
Nice. Yeah.
And I ordered it from Ottawa. I looked at it, and sure enough, if you look where our house is, and I overlaid it on Google Earth, the front of our house, there's a dark spot running across the field to where the lake was, and that was the old channel that used to feed, prehistoric channel that fed the lake and then would go off down towards the river valley. So when the big flood happened, it was still active and moving through the old channel in front of our house, removing materials and floodwaters coming up and such.
No way.
But when you put a drone in the air, often for some of these applications, if I remember there's an older scientist I used to hang out with a bit, and he'd show me things like, even on Google Earth, like, I can't believe this stuff is free. It's so amazing. He'd show me how you interpret some of that, and you look at it and say, listen, you're looking with a visual camera from the air, but there's indications of what's going on just by color differences or how it looks like. And there's a lot of data you can pull out even that way. So
cool.
Wow, interesting. Yeah.
It's and then when you add on like photogrammetry and LiDAR and start to do like contour plots or something, or topography, then you're adding a whole nother element of information on there as well. So
the LiDAR stuff is pretty neat.
It's fascinating. It's really interesting what you can do with it and the precision of it. It's expensive to get into.
Sure.
But it's all the time. It's getting better and getting smaller, getting, more accurate. So,
I think even the iPhone 12s come with LiDAR on them now.
Oh, really?
Yeah. You can actually like scan stuff with your phone and it'll create a 3D representation of it on your phone. Augmented reality. Yeah.
That's crazy. I had no idea.
It's pretty crazy. I think it's still kind of being like, the phones are out, you can use them, but like it's going to be on your phone. Like I've seen videos on YouTube, they're scanning old muscle cars and stuff with them to get the fender part and like measurements off of it and stuff like that.
Then 3D printed off. There you go.
Maybe, you could do that instead of having to order all those expensive parts, right?
Yeah. Well, that's one of the issues you run into, because so let's say someone knows that and they know that you can do LiDAR with a phone. But then you put the LEOs 2 in a vessel and they, hey, can you do LiDAR? And you're like, oh, no, I can't. But my phone can do it. And it's like, okay, number one, not really the same. We've got apples and oranges for like actual LiDAR.
Strap the phone to it.
Okay.
Yeah.
I don't know if you guys have...
I would just tape it on there. Why not?
I don't know if you guys have seen the video of Zach Wilde playing on a Hello Kitty guitar on YouTube. If you haven't, you should watch it. It's amazing. It makes me want to never pick up a guitar again. You're like, I'm not worthy. but he wouldn't go on stage and charge big ticket prices, and do that with a Hello Kitty guitar. It's very similar, right? Like, okay, there's things you can do with technology. And people, we were talking about this a little bit before, there's this tendency to have a bit of resistance because you think about what you did in the past and what you're used to and what you're comfortable with, what there's rules and regulations and methodologies related to. But then you watch Star Trek and you're like, yeah, but you see that tricorder thing they got, or that, and you're like, okay, right now there's a certain level of technology we have that we can leverage and use very well, but we should use what we have right now the best way we can. So the resistance isn't helping too much. And the being dreamy about what might be and will be one day is good to think about, but it's not going to help us too much. But where are we at right now? And like, say with LiDAR, when you talk about a system that you put on a tripod and you're going to do like a 3D mapping of above ground structures of some sort, a good system, you're talking millimeter accuracy. But when you talk about visual inspection, you want to measure something, millimeter accuracy isn't sufficient. So, and when you talk about handheld systems or systems you mount on a drone, you're talking centimeter accuracy. And they're not small enough and light enough to go on the LEOS 2. And the LEOS 2 is never built to carry additional payloads. Right. So, it's the right idea, but we're just not there yet.
It's not there yet.
Yeah. So
it's kind of combining two things that aren't really meant to be yet.
No, it's right. That's right.
So what is that, like, getting back to that, what is... What does a deliverable look like? Is that something that you can just hand over and anybody can open that up on their computer, or like
yes.
What exactly do you get?
But it all depends what people want. And that's every site has their own way of and every inspector, every person, or every application has their own kind of deliverable they're looking for. We can have a standard deliverable. We can give somebody a video. We can give somebody images of areas of interest. We can develop a 3D model of something, if that's useful.
Yeah, the 3D model I'm more kind of interested in. The video and the photo, okay, I get that.
Know that. Yeah, exactly.
But some of the other stuff, is that just compatible to hand over and anybody can have that information?
Yeah, it's something you can open up and anyone can have the information. But usually when you get to that level, people are putting it into other software suites of some sort. So you're looking at a GIS software or some sort of CAD software that they're already using for that sort of purpose. So if you're working for engineers on, say, bridges or building science or something like that, they will have the ability to open it up and integrate that with their own record keeping and the way they look at stuff. And that's one of the big questions that comes out of a lot of this. I know there's a good video on the Flyability site where a couple of the inspectors, I think one of the companies down in the States is looking at going entirely at getting rid of manned entries, going towards the remote inspections. And what all's involved? How do you do it? And what they've found is that you can gather a lot of data very quickly with things like Elios platform with robotic. But who's going to be looking at it? What do they need to do with it? How are they going to store it? How are they going to access it? And their metaphor for it is like drinking from the fire hose, right? And so that's, from our perspective, one of the things we like to do for dealing with clients early on is say, who's going to look at this and how do you want it given to you? Like, what do you need at the other end of it? Because there's so many options.
Right.
And when you guys do the standard non-destructive testing, you have very specific formats that are tried and true for what you give for results, how you draw things out, how you describe things, how you file them. But when it comes to these new technologies, the sky's kind of the limit, right? So it depends what you're looking at.
Yes, I do. I do definitely understand that. And I don't know. I think I would want a full report, because not to knock resident inspectors or anything like that, but at the end of the day, they want like a thumbs up or a thumbs down. And like you said, it's a fire hose of information, and they typically have such a high workload that they don't have time to sit through and pour through everything. So like, I think a deliverable of like a thumbs up, thumbs down is something that they are looking for. And whether or not they specify that in their contract with you guys, like, is that something on a standard kind of deliverable? It doesn't have to be through Maverick or anything, but just how you would interpret it. Like, you can just give someone a bunch of raw footage and some photos and be like, here's your internal inspection. Or do you guys try to interpret it a little bit and say, tray level 25, we found pitting, which we estimate to be at this size on the, northwest corner, the, 11 o'clock portion of the shell. Is something like that more of a deliverable?
Yeah, exactly. As far as measuring the size of features, making calls on things, I mean, we don't want to be doing that side of it, but saying apparent pitting, like you say, whatever o'clock position on that side, here's the pictures of it, here's where we found it. You should check that out. Whether you do UT from the outside, you go inside and look at it. And that's what I was like, to give them kind of the highlights reel. You say, here's the whole video. You can watch it. Here's the snapshots of what we saw that we think is of interest. And then they can, pursue it from there. But even that, I mean, and this gets back to, are we there to replacing visual inspectors? I remember years ago, that same steam header type job. You're going down a steam header in the ligament between two pipes, you see a linear indication. I'm like, I'm pretty sure that's scale, but I'm going to take a picture and give it to the client. Yeah. And then the client gets the poor UT guy to keep scanning it until he says it's a crack. And you're like, well, I don't think it was a crack. He didn't think it was a crack, but they're sure looking at the video that, and I was pretty sure it was scale. But that is one of those limitations, is that you've kind of opened a can of worms when you find something, you point it out. Then the follow-up has to be, what you rely on more so than the actual video image. And that is something that, like, looking at video is not the same as using your eye. There's like, the video is really good and you can see a lot. And like the Elios is done, like you guys were talking about before, you have the oblique lighting, you have the 4K camera, you have the ability to get a lot more than you would with, say, just a camera where the lighting and the video and everything are moving in the same, from the same plane. Even before the Elios was around, I'd often use multiple light sources inside something and move them around, or, turn an auxiliary light on and off and the light on the camera head on and off to get that exact same sort of abilities, like using a flashlight and going across something. Is it a pit or a bump, right? Like it's hard to tell unless you move the light around. But I think things look different under video and when light hits things and you get a little glare off things. And the other thing to remember is as good as the video is, our human eye is a fantastic instrument. I actually had to look this up because I didn't know. A 4K camera calculates out at 8.3 megapixels, I think. The human eye is 576.
Yeah.
So, and the refresh rate on the human eye is just fantastic. I mean, so we are it's taken nature hundreds of thousands of years to create such an amazing machine as us. So to be able to say that, well, we're already there with the camera systems and the ability we have to totally replace a human inspector, I don't think that's realistic. You're overselling the technology at that point. So.
Yeah, and it kind of goes back to what we were saying earlier of how it's almost like a team effort where you have the pilot who's a specialist in flying that drone, and then you have the inspector that's looking at it. And you really shouldn't be trying to interpret things if you're not the specialist in that field, right? Like I think the way you laid it out is really all you can do, kind of the high level. There's something going on here. You might want to have a look at it. You might want to evaluate this.
Yeah.
You mentioned measuring areas of pitting or something like that. Is there any way to measure depths yet? Is that a thing yet, or is that still kind of a Star Trek technology?
We've had success in the past with very limited applications measuring pits off video without using, say, a really, really expensive video probe in a very specific situation with, fancy software built into it. We used a third-party software at one point for doing tubes and found they were very precise, but the tubes had to be very clean. Mm-hmm. You had to say what your focal distance out was, what your lens was, what the diameter of the tube was, put it all and be very precise. And if you were good with it, we actually did testing where they split the tubes and we were pretty much dead on with all the depths. Wow. But there's the question of for how much effort and everything else you do to put in to get that. There's many things you can do, but the question is it the right solution? If there's an actual engineered solution built for a specific purpose, it's always the first thing you go to because it's built for that purpose. But if there isn't, that's usually something you can do. It's just how much effort, how much time, how much work does it do it? Or, and again, it goes to that kind of Star Trek thing. Like there's often, you can find a solution somewhere in the world for something, but how expensive is it? Is it something that's even available for commercial use? Mm-hmm. I've researched different technologies for clients before and said, well, here's a solution out of Europe. And they don't rent it. They won't let us get it. They'll come do the service, and here's how much it costs. And after that, it's just kind of crickets.
That's where it ends, yeah.
Yeah, I think Cortland said the Helios has a millimeter of resolution or something like crazy. Like it may not be that small, but like maybe an eighth of an inch of resolution for linear indication, let's say, detection.
Yeah, that's right.
Like it's pretty ridiculous.
Well, but as you get closer to something with a video camera, it gets bigger and bigger and bigger, and the farther away you get, the smaller it gets. Yeah. So there is that side of it too. You'd have to do a video inspection. A client will say, "What's the magnification of your camera?" And you kind of go, it's gonna be one of those conversations like, "Well, what's the magnification of your eye? How big is that person out there across the field, or how big is it?" It's the same sort of thing, right? But if you know the dimensions of some things in an image, you know how far everything is relative to each other, then you can calculate some of those.
So like currently, if you're flying into that trade tower with your Helios 2, you can't give pit depths.
No,
that's not quite a thing yet.
No, it's not there yet. No.
Well, you got to strap the iPhone 12 with the LiDAR.
If you put the iPhone 12 on it though, then you can. Right?
That's pretty.
Definitely want to tether that off.
That's Well, I don't know. They're both pretty expensive, but I think the Helios
that's exactly what I was thinking. Here's making a more expensive thing to.
Yeah, you don't want to lose either one at that point.
It's adding about $1,300 onto the Helios. Yeah. So, aside from this stuff, like I know a lot of the stuff is used for outside, especially the thermography and the LiDAR and stuff like that. Like, do you guys map a lot of vessels, or is that mostly kind of geological surveys and like say structural stuff maybe?
We're getting more into the 3D scanning and the mapping of but a lot of the bigger facilities have already gone down that path and have a lot of that information put in place in their own systems. So we'll be adding on to or augmenting to that side of it. Most of the things that we map out would be subsurface at this point, and then we're tying it into the the above ground features. So the geomatics side, that's the bigger umbrella where you're positioning everything in space, whether it's underground, underwater, in the air, on the ground, tying it all together. And that's where everything is going. I mean, the whole virtual world, the whole augmented reality, they'll come to the point before too long. And the software's there. It's moving towards it more and more, where when you get a utility locate done, you'll just take your phone and just look at the ground and see where things are, because it'll all be mapped in. It'll show you in kind of a pseudo 3D sort of view.
Yeah.
That software and technology is there, but it's still moving towards it as far as industry goes and being standardized. So that's where, for our focus has been more that side. But the above ground stuff, especially the digital twinning of projects, every time a project comes up, that's very big. So we're getting more into that side of things as well. So mapping out in 3D.
Yeah, I've been on jobs where I was creating corrosion circuit drawings by hand, and there were other companies out there who were doing digital mapping at the same time, and they were trying to sell the fact that from their digital 3D mapping, they could isolate specific lines and then recreate corrosion circuits just based off their digital mapping. Is that something that's real, or is that even possible to your knowledge? Or do you still think kind of like...
So you'd still have... Okay, I'm just trying to follow through. You said you'd still have somebody doing the corrosion survey and they're just adding that data to their map?
Actually creating following a specific line and creating, say, like a CAD drawing from my handmade drawings, right? Could you extract that from a digital laser scan or some sort of 3D scan from a drone or any other piece of equipment that does that?
Okay.
Is that a weird... I know that might be...
I just try to make sure I answered the right question and answer it correctly.
Like removing the hand sketch step out of it? Is that what you're getting at?
Or taking the hand sketch and adding that data set to the 3D model in that case.
Well, you could look at it that way, either or. But like I was thinking more so extracting it and then using it, because I know some plants or facilities use 3D modeling for their piping, and then they use those drawings for their corrosion circuits, right, for their corrosion surveys, right? So if your Maverick techs came out, they'd be like, here is the piece of piping that extends from point A to point B. Can you go do UT et al. Or CML locations on that? If you were to 3D map that facility, would you be able to segregate separate lines out from that information and recreate those types of things for that company?
Okay, yeah, exactly. So I'll give you an example of something we were just actually working at our warehouse. So I have the refractory sample on the wall.
Yeah.
We fly it, we build a model, and then we put a couple of targets near it on the wall. Yeah. And we take our survey grade equipment and we know exactly where those targets are. We go outside the building and we shoot in a couple of points, and then we put the drone in the air and we map out the entire structure and do a model of the building. Then we can say, based on any point outside the building, where some refractory loss is on the model and how they all relate to each other. So getting it all in that same 3D space, if you're building a model, you can tie it into everything else around you if the model exists to tie it into, or you're developing the model as you go. So yeah, that's very doable. Yeah.
Wow. What if it's something that doesn't exist yet? Say it's a new facility. Can you go and scan the whole thing and then create that?
As far as...
like the whole 3D model itself? So you could...
Yeah, so that would usually be done, say, by the people designing the facility would create that model.
Right.
So if it doesn't exist yet, I mean, there's nothing to scan as far as that goes, but...
No, like say the physical plant exists, could you create a 3D model with your technology? So you could go and scan that and create one?
Yeah. So like say the 3D LiDAR, the scanners, you can, to millimeter accuracy, you can create models of pretty much any structure. So, and then,
interesting.
Yeah, and then survey it in and get actual, locked in points that you use for references. No, for sure. And that's where everything is basically going. Doesn't matter what you're doing. It's all going to that 3D space and the mapping and the modeling. So.
And it's mostly like surveyors who do that type of work, right?
Yeah. Well, that's not necessarily under the umbrella of, say, land surveying. Land surveying is more when you are certifying things or you're using, actual property boundaries and real property reports, those sort of products. What we're talking about at that point is more the larger umbrella, like instead of geomatics, which you're just putting things into the 3D space. So it's a very similar skill set. It just doesn't require, it's not the same level of governance and certification. So you're not stamping and certifying and say, this is this point relative to, the surveyed parcel or whatever. Yeah, you're saying this is this point relative to the globe and all the locked in points and what we know it is. So yeah.
That's pretty interesting.
Yeah.
So, geez, I don't know. I feel like we haven't even looked at our whiteboard in so long.
I was going to say we've been neglecting the whiteboard.
Kind of the way
here.
it goes. Yeah.
So, aside from the conversations you have with the client before you get on site with what the deliverables are and stuff like that, is there anything that they think your equipment can do that it can't, and then you kind of have to rein them back in a little bit? Like, do you have to say, well, look, it's not quite there? I know you kind of gave an example of like, yeah, they have some obscure technology in Europe, but we got to fly the whole team out because they don't rent that stuff. Is like, do you ever get like weird requests for stuff that might be out of the realm of your equipment?
To some extent, I think more often you get weird requests for things that they just don't know what technology to even approach it with, and they come to you and say, "Listen, this is our problem. What would you throw at it?" And often we're like, "Well, this, or this," or we're like, "Don't know. I'd have to look." Or we don't have the solution, like Court was saying before. But this guy over there does have the solution for you. So it's more so that side of thing. I think people nowadays are, especially with the internet, they're pretty good. They can figure out how things work. Sometimes that just makes them dangerous because then they go on the internet and, they start asking questions. You're like, oh, you're on the internet. Those are the wrong questions. But that's okay. That's okay. We'll work through it with you. But infrared's probably the worst one because Hollywood has totally destroyed people's idea of what infrared does.
Yeah.
Like Aliens versus Predator.
Yeah.
Every time they're like, just turn on the thermals and through kilometers of ice. Oh, there it is. I see a heat signature. I'm like, my wife's like, that's the part you're complaining about in this whole movie? Really?
You mean it doesn't work like that?
Yeah.
But that is the thing. And that's something we talked about with, certification and training. So I had quite a bit of experience with the infrared back in the day. And now say my drone pilot, I'll send him on a level 1 infrared course. But I know when he comes out of that course, he'll have a basic level of knowledge, a starting point. We have a shared vocabulary. He understands, the basics of it. Mm-hmm. But it's like you guys, you go take your tickets and then you come out of school. But after that, there's the real education, the real learning happens when you start looking at real applications, you see different things. And it's the same with the infrared. So I work with him and I'll say, okay, building science, let's take this building, let's do a scan of it, and then we'll go through the software later and I'll show you things and show you, what you can and can't see in this building based on the construction, and we'll find things on it. And just how you approach things, how infrared works a little more in depth. And I think that's one of the dangers right now with technology emerging so fast and I understand from the manufacturer's perspective because their role is to create technology, get technology out, get people comfortable enough to create more technology and get more technology out. And that's what drives all this development. So it's a good thing. But on the other side, when somebody says, here's a ground penetrating radar unit, here's a 2-day course, now you can go locate utilities. And we're like, for us, just regular locate technology like the wands you see for what we do, that's probably 1.5 years being a helper before we turn you loose. That's the most basic. And it's one of those scenarios where it even creeps into when you're bidding on jobs. Let's say there's a large construction project, a pipeline project or something, and there's a lot of ground disturbance work. And you're talking to the people who are doing the bidding and the all of the procurement. And they'll say, okay, you need this 2-day course to do it. This certification is required. And we look at it, well, okay, we go look at it and you see, okay, this is a 2-day course. There's no governing body or curriculum that has said you must do this, 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 this. This is somebody who has some experience in the industry put together a 2-day course. Mm-hmm. But if that's what you're basing your contractor on, when we won't let somebody out on their own, even after like over 1 year to do that sort of work, but the person who's asking for it just has a checkbox in front of them. How the checkbox got on the whole procurement process is really where the problem comes from. But then you have to say, okay, we can send our guys on this 2-day course, but you realize that that's not sufficient. That's not how it should be done.
Yeah, to have that alone.
Yeah.
Yeah, that's a good point. Like we talked about that kind of, I think, in our certs episode, where once you do get a cert, say you're 510 or something like that, it's basically just a ticket that allows you to start learning now. It doesn't mean you know necessarily anything yet.
No, exactly. Yeah. And you never stop learning. Like it just never ends. Wow. Even if technology doesn't change, you never stop learning.
Sure, yeah.
So, and that's one thing too, when you look at the use of the UAVs versus the use of a visual inspector. I think there's something about working on the same facilities and working on a range of facilities and seeing things in real life that builds a body of knowledge, and it's just a lifetime of knowledge. I don't think you can replicate that with technology. At least at this point, you can't replicate that with technology. So it's one of those. I like to. This is one of the reasons, like say, I got so excited about you guys talking in the pandemic one, is because imagine you're standing on a beach and there's a giant wave coming at you, right? And it's massive, like it's a crushing wave, and you got your surfboard. You're like, if you can get on the right point of that wave and ride it, it's glorious. But you got to get on the right part of that wave and understand how to use the technology, what level of skill is required, what levels of equipment required. And today's world, when technology is moving so fast, and it's moving in these zones like where Maverick exists, this kind of nebulous zone between all the established, standardized, and regulated boxes, having that fingertip feeling for where you should be with the technology and how you can use it is very subtle. It's something that takes a lot of experience as well. So that's where I think that combination of the human and the machine, like your guys' knowledge, your guys' experience, as the technology develops, we're not at the point yet where we're humans living in the machine's world. We're still kind of got a foot on both camps. I mean, we've come from the point where it was a human world where machines were working for us. And now we're kind of working together, and the human-machine interface is getting blurred more and more all the time.
Yeah.
You look at your phone, like if you can't find your phone, you're walking around the house, it's like you're missing a limb. Like where you stop and your phone begins is getting, a smaller and smaller margin all the time. And there's going to come a point where it will no longer be an external device.
Yeah.
Like, we're going to get to that point. Like there's the technology is evolving. It's evolving very quickly. And I think a lot of the discomfort that people feel about adopting technology is just how rapidly that curve is changing. It's just how quickly we're moving forward. And it's moving forwards faster than I think as humans we're able to adapt to it and understand it and use it. And it is one of my concerns moving forwards. You look at things like artificial intelligence, and is it being developed by people who are operating under governing bodies with strict rules, say military labs somewhere or government? No, it's the big kind of corporations of the world that are racing each other to see what product they can get out as fast as possible with as little restrictions on what they're doing as possible. And you're like, well, it's kind of an interesting, fun, and dangerous game. So let's see how it kind of turns out. And I think that's like kind of the extreme example and what we see it happening. But I suspect some of the resistance is that sort of feeling that it's like the self-driving cars. I drive my old 91 Jeep Cherokee. I love being in control. I like being the driver. If you go to something where the car is driving for you, then you're like, well, now I'm a passenger.
Yeah.
And then I don't know what steps go beyond that and where it goes. So that's...
Yeah, well, you have no control of it at that point. You're just along for the ride.
Yeah, as long as you have control over your destination, I guess that's all that matters, right?
Sure.
Well, they just want you to look at your phone in between, right?
Exactly. So,
You don't even know what's going on just looking at your phone.
Well, you're right. Like that's what's exciting about this technology, but it's also dangerous is that it's limited by only people's imaginations and
that's right.
what people can do with the technology. And at that AI point where you can tell a computer to almost make another computer program for you because you're not smart enough to make it. And whether or not you can understand it or control it or not is going to be the end result, right? And it's kind of strange but fun at the same time. So there is a lot of stuff and
it's hard to keep it coloring within the lines, even when they try to, because I remember reading a story recently. So they want to keep the hands on the controls, a human in the loop for autonomous machines that can be used for war and can kill people, which seems like a really good idea. But then, I think it was the U.S. military came out and said, well, but what if the enemy has a swarm of drones without the hands on the control? We can't have a hand on the control to react to it because you won't be able to react fast enough. So we have to take the hands off the controls. And so now you've seen that they drew the line, but the development moved so fast that the line just became obsolete almost as soon as it was drawn. So, and that's part of that whole, like you say, you see the wave and you can ride it and it's awesome and it's fun and it's exciting, but part of the excitement is it's also dangerous and it has a lot of power and a lot of momentum behind it. So
yeah, well, swarm drones in the military sense are just dangerous and scary.
It's kind of sounding like the Terminator here.
Well, it is.
Yeah, I'm that age. I grew up around that, so I would just go there. It's just natural for me. So that's right.
So, out of all this kind of stuff, what's your favorite kind of technology so far?
It's the UAVs for sure. Just because they're just so adaptable, so flexible, and they just blow me away. I remember the first UAV I saw, like what we think of now, a quadcopter. probably 15 years ago.
Really?
I think it was about $30,000, and a Maverick now that would be, just over $1,000 or whatever, under $2,000, would just blow it out of the water.
Yeah.
But it was, as soon as I saw it, I'm like, this is where everything's going, but there's no point getting into it now because who's going to use it? How they can, it was law enforcement was using those type of things, mostly search and rescue. Like, it was very limited, but I was, even right there, I was like, this is amazing. This is where it's all going to go. This is.
Yeah, it's probably 4 times the size of a Mavic.
Yeah, well, it was pretty impressive even at the time. Like, it was pretty impressive. But yeah, now, yeah, for sure, yeah, the UAVs I think are definitely my favorite. Yeah. Although there's something about the robotic crawlers, just 'cause I use them so much, and they're just, it's like a tank, and there is something about, and also having, because we have some that are just. We have explosion-proof ones that we got CSA rated. They're very particular machines. We can't modify it. We can't alter it. It is what it is. You can't even change a screw on it with a different type of screw because you can't mess with the rating. And they're fantastic. But we have some older systems that are modular, like the ones I use to put in the steam header of different sizes that I can take apart, I can put together. It's like a Lego box. Yeah. And so if I want to start adding more sensors, I want to start adding different types of instrumentation packages to it, nothing stops me. It's the sky's the limit. So I very much enjoy that because as soon as you get an aerial platform, you have weight restrictions, maneuverability, all these things, but a big tank, you can strap a lot on a tank. So,
well, especially something that's tethered and has infinite power, right?
That's right.
When I was talking to Cortland, he said some of the larger drones, depending on the payload, may have like a 6 or 7 minute flight time.
Yeah.
Right.
Yeah.
Which we said kind of didn't sound like a lot, but you could gather a lot of information depending on your payload in that 6 or 7 minutes.
Yeah.
Right. And it's just, again, another fire hose of information that you gotta, that you gotta interpret once you land it again. So,
and there's some interesting payloads showing up on drones that the UAVs that you couldn't put on in the past because they've overcome some of the challenges. But things like the magnetic radiometry, the even ground penetrating radar in some applications, you have to be very, particular and careful with it. But there's a lot of stuff you can do that's becoming aerial as well that wasn't that many years ago was very difficult to do with it. So it's like I say, everything's changing very quickly, and it's interesting to see where it all goes and what happens with it. So
yeah, I mean, they even have those ones that like you spray your crops and stuff with. Can you imagine the weight that when it's full, it's amazing.
Yeah, and I think part of it is they have to carry less product because they can pinpoint it because you're not just spraying the crop with it, you're flying ahead of time, and your landman is actually saying, here's where you spray and here's how much you spray based on the other data they've gathered for what you need for whether it's pesticide or fertilizer or anything else. So you're very precise with it. It's fantastic. I was talking to a farmer with a very large operation recently. I was doing a infrared scanning of his garage floor to map out some infrared heating lines. And he was talking about the operation they use. And he said they used to think it would get bigger and bigger machines. Right. What's happened instead is smaller machines, but multiples of them moving in like a swarm driving around the field, and they never stop moving. And the machines that empty the machines never stop moving. And the human operator inside is not operating anything because we're too imprecise to do it efficiently. Right. What we're doing is watching all the cameras to make sure that all the various processes are functioning properly as you go. And it's fantastic how it's like, it boggles my mind. I live in the future. Like I'm half a century old now. I think next month I'll be 50. and I look at back in the 80s or the 70s, and I look at now and I'm like, this is awesome. I live in the future. This is just so cool.
Went from piano neckties to drones with LiDAR and photo telemetry, right? Actually, I know this is definitely not a farming show, but I ran into a farmer hunting one time, and we actually did talk about the drones. And Scott, this is when we first kind of got into drones when we met Cortland, is they're going to have cameras on drones that can actually distinguish between weeds and crop. And then that way they don't have to actually spray pesticide on the whole field. They can target only the weeds within the mix and do that. And then you need less of a payload. But those drones that I think they were M300s that
same kind of size anyways.
That had the tanks on them, and then you would use a Phantom to go out and map the area. You'd upload that data to the M300 and it would go out with the sprayer and spray it, right? And that's kind of what intrigued us about drones, and we ended up after that job we both ran out and we bought Mavics.
Exactly.
I still fly actually because of the weather. It's been pretty cold lately, but I flew mine actually just last week for like an hour, and I was like, oh my God, I forgot how amazing this was.
Oh, yeah.
Right.
That's a good example, though, of using the technology. So what you're doing there is, in the old days, you'd say, I have a process. It goes from this point to that point.
Yeah.
I think we might have talked about this a bit before, but it comes from other industries and such, different project management methodologies, but I think they call it like a waterfall method rather. You try to go through a process from point A to point B. And when you get to the end, you look back and be like, it was pretty good, kind of a rough fit, but we did okay. Mm-hmm. Now, if you look at a newer method where they're more, they call it like agile or lean methodologies, where you do little sprints, little steps, but they're not complete. But each step informs the next step. And so by the time you get out to the other end, you were more efficient and you met your goals more accurately. So that's very much like how, they're doing in farming now with the crops. Because in farming, like the difference in profit, when you're not using as much product, you're not using as much fuel, you're getting more crop off the field because you're using all the instrumentation and all the technology. And I think that's where, on the industrial side, to kind of circle back around what we were talking about, when you start using things like the Elios in the way we were talking about for visual inspection, that's exactly what you're doing. You're not saying we're going to build scaffolds in all these vessels. You're saying we're going to find out how much scaffolding we need to build. Mm-hmm. Like say you guys said that in your pandemic one, and I was like, get my notepad. This is awesome. These guys are saying this is how it should be. Like you guys are looking at the wave and you're not scared. You're like,
right.
We're going to ride this thing. This is awesome. This is how it should be done. So, yeah.
Well, we got to figure out how to stay relevant, right? Like even...
Well, it's all about efficiency too, right? I don't think it's any technologies to replace anything necessarily. No. It's to make it more efficient.
Yeah.
And that's a great example of going through the vessels and finding out which ones need scaffolding, which ones you don't even need to go in again. And then even to pinpoint the scaffolding, like why build it all the way up when your area of interest is only the bottom or something, right?
Yeah. And like you're saying, towers, overhead pipe racks, you don't need to get a person up there and look at it all right off the get-go. You can do it remotely, then pinpoint with scissor lifts or whatever else where you want to go look at, what repairs you want to do, what you want to look at more. And same with what you pointed out before with towers. There's elements of towers, cladding, various things you can't see unless you have a certain viewpoint, certain perspective that you can really get nicely from the air. So it's a huge benefit. But it's also convincing the overall system to adopt it during the planning stage of a turnaround, that you're actually going to use that methodology to go through and use it to be more efficient. And I don't think we're at the point yet where people have adopted or, brought that sort of idea in fully. I don't know. I'm not a turnaround planner, so I'm not in the room when they do that, but I assume that's just not where we're at.
Well, I don't think it's really in the template yet. And it's too easy to go through everything and do it the same way you did last time and follow the same template. And
copy
it's kind
paste.
And it's the idea of bringing something else in.
Yeah.
That's, I think, is the hard part. But it's coming and it'll get there.
Oh, it totally is. It totally is.
Well, from that perspective, like that's where Scott and I kind of think as contractors, where we can provide value to our quote unquote clients is, having exposure to these type of technologies where we can say, hey, we know a company that does this and it's an option for you guys, as opposed to building that scaffold or being stuck and waiting until you have to bring that piece of equipment down to check something out. Right. So having that knowledge and being able to relay that to the people we work for adds value to us, because these guys seem like they know stuff. Well, we should keep bringing them back. Right.
Well, and the other side too, to think about is that you can create technology fairly rapidly now. You can create pilots fairly rapidly because the technology is getting easier to fly. But what you can't create rapidly is that lifetime of knowledge and understanding of the trade and what you're doing and what you're looking at. And if we've learned anything from the development of technology recently, you can see that people have big expectations of what it can do. But look at the self-driving cars and all the issues they've been having.
Right.
It's the same sort of thing. There's going to be a role for a very long time to come for that kind of brain trust, that lifetime of knowledge, that wealth of information you have, that you can make judgment calls, you can make decisions that take a little bit more in-depth understanding. It's not just a 1-0 on-off necessarily. It's, well, let me scrape at this a bit and poke at it and look at it from a couple of different angles. Yeah. Being able to hold something up and look at it from different perspectives almost. That is one of your skills that the technology, at least to this point, doesn't have. And it'll take a long time to get to the point where it's that powerful, where you have that much of a, an algorithm or, processing ability to do that sort of thing. So I don't see, it shouldn't be something seen so much as threatening as just complementary, that it really enhances what you guys do. Like it moves it forward. So
yeah, well, just like when at the beginning of the episode, when you said you did enough thermography on these amine towers, contactor towers, that you would kind of already know the symptoms just based off the type of thermal imaging you got off of it, or even talking to the operations before you went out and did it, right?
Exactly. That's right.
So, and I know being at facilities where you talk to someone who's been there since it was piles in the ground, and this happened during construction, and then, the great 1984 upset in the plant when this happened, and you know what I mean? Like, having that level of experience and knowledge won't ever replace a computer, not yet, or at least any program that can data mine or sort through stuff and then spit out an answer, because it's still going to have only a certain percentage of accuracy, whereas that human brain and that human experience can kind of pinpoint and put all those data points together and be like, okay, I think this is what it is. And then when you get a team of those people together, it's quite the experience. Like, even we've been in turnaround situations where we found something and like trying to figure out a solution where you're working with a process engineer, a mechanical engineer, chemical engineers, materials engineers, and then and then you're sitting there, expected to put your input just based off your inspection knowledge. You're like, I don't really belong with all these people who spent a decade in school learning all their stuff, and then they're asking me about repair regulations that we have to follow. Like, it's really weird, but like, you do have your little sliver to chip in and put in, right?
Everyone's a piece of the puzzle there.
Yeah. So it's really neat, but like adding the technology into that and leveraging it is something that should be embraced by everybody, I think.
No, for sure. The confined space entry aspect is something a lot of like the asset owners, a lot of bigger inspection companies are working on as groups right now to eventually eliminate in one way or the other. So the human might not be in the vessel anymore. But again, like looking for the Titanic, right? You're basically there, right? You're still there.
Who's going to take those tray manways out? Sorry.
That's right.
I thought you were thinking Manwatch. Like, geez, the title of the show. How can you not think of that
word? That's a super, like, it's underestimated that the Boilermakers go in there first while it's dirty, let alone to take all those tray manways out just so you could get a 3D head in there to bash them all up. You know what I mean? So like there is a human element that may not be eliminated entirely, but definitely I can see it being reduced because you're not supposed to be in there. It's not designed for you to be in there. Yeah.
And the ways in which the human element will be augmented as technology advances too, because you look at places like Japan where you have a aging workforce and they're having to deal with that. Exoskeletons are becoming more common, something they're developing. It's fantastic. And we look at it as if science fiction, but it's happening. You get manufacturing processes where you don't have enough workers and workers are too expensive or not interested in it, and you automate it. And I've heard of economic models where the workers now own a piece of the machines, almost like a stock market. They pay for the maintenance and everything else, and they get the rewards of the machine's work.
Oh, yeah.
And there's like, at this point, when we look towards the future, we're looking at it from where we are and where we've been, but it's so wide open. It can go so many different places that it's mind boggling to think about, right? Like where it could be and where you could end up. So I think a lot of times, I mean, we have reason to be concerned about our relationship with automation, with machines, where it's going, but we also have a lot of opportunity. You should keep an open mind about where it's going, because who knows, right? I mean, it could be fantastic. I would love to be, sitting in the mountains and say to my replicator, Earl Grey tea hot, and have my Earl Grey tea, and I don't have to worry about, groceries or survival and everything. And I mean, that's kind of where automation is going. The path between here and there, I don't know, but that's, that Star Trek future is kind of you're in Starfleet for the glory of it, not because you have to put food on the table, right? So that is kind of the far flung reaches. So from our perspective, where we are now, we see the immediate and we're like, well, how's that going to affect what I do now? But 20 years from now, like the world is changing so fast, it is hard to imagine 20 years from now.
It really is. Yeah.
Almost. Yeah. And it is a little bit weird, but yeah, I I guess in that 20 years, I do envision myself sitting down, having some Earl Grey tea and relaxing.
Right. Yeah, exactly. Eventually, that's the idea. Yeah. Well, ideally, you're doing it beside your computer while the robot's inside the vessel, and you're just
You could, I don't even want to be looking at that, to be honest. But Boston Dynamics actually had that video not too long ago. I don't know if you guys seen it. They had that one robot. Like they obviously have the Spot, which is like a dog one.
Yeah.
But then they had the humanoid kind of one. They were dancing. Two of them were dancing to a song. And then the Spot one came in and it started dancing. Like I remember just a couple years ago, like those things had to be tethered, right? To even stand.
Yeah.
Right. Yeah. And now they're dancing and jumping and doing flips and going over obstacles. Yeah. And that Spot robot, now they've integrated some sort of like reaching arm.
They call it the arm. It looks like a head to me, but sure. Yeah. It's the arm.
It does. It looks like a mini brontosaurus head or something like that. Right. And it's getting weird. And I think actually that one online seminar, they had a similar Spot robot, dog type robot that would go through the facility and search for gas detection and stuff, or rescue, right?
Big on gas detection, some of those. But that too was like, a lot of those demonstrations were like, it was more advertising than reality. It was like, here's some, things that we can do, but when the questions come of when we can implement them, it's like, well, you can't really yet. This is more of a thought or like a lab testing thing right now, but it will be there eventually. So,
and there's that price point too.
Like right now, that's exactly.
I could go buy one of those Spot dogs, but without any arm, anything. I think what is it, $75,000? I think for one. Mm-hmm. I go buy one, but if I had an application for it, maybe, I'd really be tempted because it'd be awfully cool, right? So,
nice toy, but expensive, right?
Yeah, and that is the thing. So, as like I said before, all this technology, it's developed for often other purposes, like even the Spot dog. That was like military originally, like a mule for troops to carry ammunition, do whatever, and whatever they do with it. And then they're looking at, how can we put this in the civilian world? What can we do with it? Infrared cameras, same, right? Like the FLIR cameras, a lot of the infrared, the early development was for the dog fights for target lock onto other jets and such, right? So that's where FLIR, forward-looking infrared, comes from as a name, right? On the nose of the jet. So then it ends up, but it has to go through this whole kind of process of development, put into platforms that are more accessible for civilian use or, outside of the industry to develop for. And the price point has to get somewhere where people are willing to use it. Yeah. So, and that's something too, like you look at something like, the Elios, it's come to the point where you can go out and you can use it. It's adaptable. It's very multi-purpose. And they've done a good job of bringing that to market, but that is where it has to get to, is that commercial viability for things.
Wow, the Elios is still the price of a pretty nice car.
Oh, well, that's what I think of is when if you were to take it down a pipe and you were to get it stuck somewhere and you don't have it again, you might as well take a Lexus to a cliff and push it off. Yeah, be like, yep.
Yeah, but I mean, at least with that, there's a lot of applications you could put it to work right away.
Oh, exactly.
So you can justify the price point a little bit. If there isn't, or you don't know what you're going to do with it right away other than entertain yourself, well, maybe it's a little hard to justify that.
Bounce it off vessel walls. Yeah, just I can handle it. Yeah. Is there anything you see coming in the future that you're excited about? That either Maverick is looking, Mavericks, that Maverick is looking at, that I don't know if you can talk about it or you want to, like, is there anything exciting that you see in the future coming along?
At this point right now, we are super focused on taking what is currently available and maximizing as much as possible. Like our measure of success is how successful our clients are getting the most they can out of the technology that exists. Yeah. A lot of the stuff coming down the pipe, I mean, it's just the same stuff we have, but better. I think, as you get faster, better processor speeds, you can deal with more data. As you get, things lighter, things more flexible, more versatile, as you get more payloads on something like the Elios, like even the things we have right now, I think, have so much room to grow that I don't see like a big disruptive technology or something really coming down the pipe that is, of that sort of level. But then again, I have to think there's a lot of stuff you see and a lot of stuff you kind of make a little check mark in the back of your mind to come back. And it's like when I first saw the first drone, right? You're like, I'll come back and look at that later and see what it's doing. So
yeah. We'll be seeing videos of on LinkedIn of Maverick Inspection strapping iPhones to the Elios, right, with the LiDAR.
What I'm waiting for is the day where when we do blind sweeps, say for utility locates. Right now you have, a advanced utility locator, you have a helper, and I often go as a helper in this if I'm available because I love getting out in the field and doing stuff. And you walk a pattern and you locate the things that you can't clamp onto and the things you don't know are there, and you induce the signal into the ground. Eventually, I see that as being something that is automated, and the technician, basically just opens the back of the truck, hits a button, there's a pre-planned path, and an automated device of some sort, just the sender receiver just do the path for you, and you have a sandwich, and they come back, and you put it all away, and all the results are all mapped out and ready to go, right? Like,
is that technology already kind of there, just not in place yet? Is that one more of a dream, or is that more of a...
That is more of a dream. That's where I see it end up going. Right. But on the other side, and this is one of those things, is that in the world, when you say is that technology there, somewhere, probably in some military contractor lab or university, there's probably something very much like that. It's just not commercially available and ready for us to use and wouldn't be cost effective. But you can see where it's all going to end up. So.
Mm-hmm. Yeah, well, even if the ranges get far enough, they might even be able to go from your shop,
exactly,
right?
Yeah,
and just out to wherever and do the survey and come back, right? A couple things I wanted to maybe circle back on, especially about the Elios platform.
Yes.
Do you guys utilize and or leverage the inspector software that comes with it?
Yeah. So that's very useful. So you know where you found things and how it all maps out relative to. Yeah. So
is it really good software? Like,
I think they came out with a new version recently of it. So it's been pretty good, and they keep updating it. So it's good software for sure.
And how receptive are they to new ideas? Like, have you guys reached out to them either about uses and or additional capabilities to that kind of stuff, or is it kind of like, okay, we made it crash tolerant, go have fun with it in whatever you're gonna chuck it in?
That is so we're in Alberta, in Canada, and we're a smaller company. It's not their biggest market. So we found this with most manufacturers, is that we've had a lot of luck bringing technology in and demoing it for various stakeholders and different asset owners and different facilities. But when it comes time to giving feedback, a lot of times they're like, But there has been some things where we show manufacturers modifications we've made to, say, their radar trucks or something for the smaller systems. And they're like, oh, that's awesome. And they just copy it and take it and do their thing. And it's all good, right? But yeah, for the most part, it's hard to give feedback to the bigger, manufacturers and such that way, because we're a small fish, right? So
fair enough.
Yeah.
It must be like some sort of kind of industry as a whole feedback that they take in, though, because even like the Elios from the original to the 2, like there's no cage in the way now, and a couple of things like that. I think you can do something with the lighting as well now.
Well, and there's lots of groups out there like Sprint Robotics where a lot of the stakeholders are involved in. So they'll actually discuss and go through all those things in the various generations and talk about it together. And so there's bigger work groups out there that workshop all that stuff and. Various levels come. In the past, we've more focused, like I say, on, say, the optical gas imaging they have now. Early days, back in the kind of early mid-2000s, the inventor of that technology, we brought it from Texas with the original prototype system, a liquid nitrogen cooled camera and all modified and stuff. And we went around to different sites and showed it off to Canadian facilities and different stakeholders to say, well, is this something you're interested in? And, those sort of things, we'll search out the technology and bring it in more so than try to change what they're doing on their end, because we're like, well, it's, you got people for that. We'll just keep bringing it in here. So, but we make our own solutions for things. If, we're like, well, if they're not going the direction we want, we might, where we can modify things, like I say, there's things, I wouldn't take the Elios 2 platform and start monkeying with it, because it's pretty dialed in, and it's been engineered specifically for a very specific purpose. But in like the instance of, say, the old crawlers we had, where we already Frankensteined it from 3 or 4 different manufacturers together in the first place. Well, it's kind of fair game for the most part, as long as you don't start ripping into electronics and doing stuff to make it like it's going to blow up or something. You can do quite a lot. So
do you guys have any Mavics in your fleet or anything? Just for general surveys?
Yeah, we have a couple of Mavics that we've used in the past. We use them for, if you're going to put it up in the air and just do a quick little bit of aerial photography or something, they work pretty good. So they're awesome little drones. So.
They're fun.
I'd like take mine out in the mountains and I'd race it as hard as I could at a tree, and it would slam on the brakes, and I'd be like, "That's awesome! Do it again!" and slam on the brakes.
Yeah.
It's amazing how smart they are.
It really is.
It is. Yeah.
It's saved me from crashing a few times, but I've still managed to. Actually, one of our last episodes, I think, was in November when we first got it, Scott. I was flying it around in the studio here, and I took a chunk out of the wall right there. Just,
you sure you want to talk about that? Does your wife even know about that yet?
Well, and that is one of the things, though. You have to be careful. And this is something in the world where we live and where things are more automated, more sensors. We get very comfortable relying on. It's like the problem they have with the self-driving cars that aren't fully self-driving, where people hack them and then sit back and watch a movie and crash into something. And it is the same. Like, you say your Maverick, right? It's using GPS for positioning. You get in some place with lots of metal around and you get your signal bouncing all over the place. Yeah. It might suddenly decide it's 20 feet off from where it actually is and go 40 kilometers an hour into the side of something.
Yeah.
So I've done that with a Mavic before, not knowing. You do that once, right? And you're like, okay, that's something that you don't do again, right? And that is one of the things is, even though there's sensors on everything, even though, say, for instance, infrared is a good example. You look at something and you get a very precise measurement with a decimal place of some sort. You have to still use the human mind, the greatest instrument you have, to understand what data went in to do that, how reliable it is, how did you get that, and can you reproduce it? Is it something that you understand how that worked? And that's one of the things, like for us, when we provide data for engineers, inspectors, anybody else, we can give them the full data set. We can give them what we've done for deliverables, and we can show that provenance and say, this is how we did it. This is the software. This is our instruments. This is the calibration. This is everything. And so they can rely on it. And if they have any questions, they can go back through and they can reproduce the same results. So, and that's very important with any kind of technology and instrumentation, is making sure you understand what it's doing and how it's doing it. A good example is early days with infrared. I was tasked with calculating very precise temperatures on a weird alloy for turbine exhaust that was like running very hot, and they had issues with failures of the turbine material on the exhaust because they're running it very hot all the time. And they installed thermocouples on it, and they put a little patch of metal over top of the thermocouple contacts on the skin. And you look at it with the camera, and you look at it with the thermocouple, and they wouldn't give you the same measurement, but they weren't measuring the same thing, because that little bit of skin over top of the contacts was more of a little bit of an internal temperature rather than surface, a little bit of cooling, a little bit of, radiant energy leaving. Same with their internal probes that they had around that section is, I looked up the specs on the internal probe, looked what the margin of error is, looked at the number that was coming out in their computer and saying, okay, everything to the left of the decimal point, about 3 places, is garbage information. You can just ignore that. It's those first 3, first hover numbers, and they'd be like, no, it's a whatever point, whatever. They're very precise. I'm like, well, yeah, but that's not the margin of error on it. And, so there's always that question with instrumentation. And you guys know this from inspection, such as that you have to know what you're measuring, know how the instrument works, and make sure you actually are measuring what you think you're measuring, get the data out that you think you're getting out of it. And that's a very common, like I said before, when you have equipment manufacturers making these systems that are more easy to use all the time, less, a lot of them, they make it so the menus are harder to get into and hard to manipulate the various settings and such, is that sometimes you fall into that trap where you trust the technology, you trust the number coming out, but you still have to make sure you're always thinking through the process and understanding how you got to that point and what it means. And that is reproducible, that is scientific, that, it's that scientific method. You know that somebody else could do the same thing, get the same result exactly with it. So,
yeah, Scott and I are actually big proponents of that. Like, if you're crawling into a vessel, like, you want to know how it operates and what the conditions it operates under to know what type of damage mechanisms you're expecting to find, right? Exactly. Or what you can find visually, or what NDE methods you need to use to find the non-visual ones, like, say, like tight linear indications, or like stress corrosion cracking or something like that, where it's not going to be some big open void that's going to be pretty blatant to you, right? So,
no, for sure.
Yeah, no, this is a good discussion, and it's a good point to bring up. Like, you don't want to fall into too much of that trust trap, or the other way where you don't trust anything at all. That's where it is important, like you said, to be able to reproduce how you got that information, or at least know how to, and have somebody else reproduce it for you, whatever it is. You don't want to just go from A to B and and just go with that and not know how you got there or everything in between.
It should always stand up to scrutiny. And the other side of that kind of trap is when people are distrustful of technology, sometimes they want to set up tests. And so, let's say you're going to, this early days, especially ground penetrating radar, when you're going to do utility locates or map out something subsurface in a field, and there's been a lot of activity in it on a site somewhere. And you ask them for some history, like, what do you expect to be there? Do you have as-built? Do you have drawings? What are you going to see? They don't want to tell you anything because they want to see what the radar is going to find. You're like, well, the best way to, it's like you said, the best way to go about something is have all knowledge at your disposal that you possibly can. Go in with your eyes wide open and have as much information. And that's one of those aspects where you have to be very careful dealing with your client, that you don't, be understanding. Yes, they want to see what it can do, and we can set up some tests or demonstrations, but when it comes time to do an actual job, you make sure that your priority is the best results and the best data you can get, regardless what it takes to do it. So.
Yeah, we actually touched on that with the episode with Ryan, where they, at the facility he was working at previously, they would send inspectors into a vessel blindly to see if they found all the old stuff that was previously identified, just to test their worth. Yeah. And it's like, well, you're wasting time and effort on the other part. Like, if he knew about all this stuff before, like, he may be able to do a follow-up inspection on it, but also spend more time on finding other things that may be more pertinent to the information. So, it's no... a little bit of phone vibration. That's not a big deal.
Well, that's a good point. And I think we even touched on that with like the NDE folks as well too. Like, if you're requesting them to do something and you don't give them any information and they give you a crap report back, well, it's kind of expected. If you didn't tell them exactly what you wanted, you didn't give them a whole lot of information, you're not going to get a lot back.
No. Well, it's kind of like going to your doctor and don't tell him any of your symptoms, just see how good he is.
See what he can find, yeah.
No, that's kind of fun though, no? This is a rash. Tell me about it. So, do you have any fun stories or anything, like a story that stands out using technology or anything like that, that you might want to talk about?
Well, one that I think about every so often, especially now that you have the Elios drones out. So, if you're doing a stack, a refractory line stack, and you want to do a refractory inspection, like most of the times up to the Elios drone, you probably take a man basket and lower a camera down inside of it and look at it, right? So and that's probably how it's been done from the beginning until now, that you have something you can fly through. I assume that's, basically but back in, I had to figure it out, 1997, I think it was. I'd never done a stack inspection, didn't know how they were done, didn't know about going up in a man basket. It just is what it is, right? And we had, I think it was a rigging company that wanted to try out how to do it without a man basket. We're like, okay, that sounds interesting. So we scratched our head a bit, and I had this old 1-ton van. It was a tank. We loved it. It looked like a 4-wheel drive. It had big tires. It was jacked up. We put a winch on the front of it, an aircraft cable, and we made a pulley system that would attach to the tip of the stack. And then we built a centering device to hang a camera head from that had, lights and everything. Used the controls from the tracks to do the lights and all that sort of good thing. And we sat in the garage and looked at it, and we was operating in Phil's garage back in those days, early days of startup, right? And we're scratching our head. Should work. Okay. So we get to site and kind of look at the stack. I'd never, this is up in northern BC. I think I'd never been up a stack or anything before. I can look at it, and the rigger says, "Okay, I'll go up and put the pulley system on there for you." So we didn't know what the flare tip or the stack top looked like when we built it. We just, okay, we got a general idea how we're going to attach it, and more or less it should work. So the guy goes up there, looks like, I have no idea. I don't know what you expect me to do. I don't know how this. So I'm like, I'm in my 20s, and like, I've never climbed up one of those before. I'm like, well, I guess I'm going to the top. So hand over hand, all the way to the top, and then get up there and get up the ladder, up against the tip, and fasten it all up there. And it worked brilliantly. It was fantastic. It just blew them away. But our client, the rigging company, looked at it and said, well, this isn't reproducible because our guys aren't going to be able to take some, homemade device you guys cooked up and go from flare tip to... And I wasn't about to go market it after climbing up that stack and down again. Not when I found out about man baskets. I was like, so that was the only time we ever did that. But that was probably the most advanced refractory inspection until the Elios came along. But I just never did it again because I was like, nope. it's all right. If someone actually asked me, I'd do it, but I wasn't going to tell them.
Yeah.
I'm amazed you had that much winch cord. Like that must have been at least a couple 100 feet up, and then all the way back down, right?
Yeah, it worked pretty well.
Wow.
Yeah.
Jeez,
yeah,
that's impressive.
And we had to run the cable up, put a weight on it, lower it down. I had to go into the bottom, hook up the device, and then I had the controller for the camera head and everything in one hand, and the winch controller in the other, so I could go up and down and then pan and tilt around and adjust the light. So it was like playing a weird video game with multiple consoles at the same time. So.
And did you have like a video stream where you could see what was happening at the time? Or did you
that was back in the day, right? So it was all VHS. So
you had like an actual VHS
Yeah, so
tape.
Everything we did back in the 90s was all in VHS. And I would, I'm kind of dating myself, but seriously, and partially because all the video inspection systems were also kind of backdated to be fit into like sewer inspection trucks and things that were operating on VHS. Mm-hmm. So I'd have a little TV VHS combo in a travel case. I'd open it up, and then I'd do the recording and everything. And as I went, I'd watch the time, and I'd watch my footage and everything, and I'd make notes inside the jacket of the VHS tape and on paper and stuff. So when I gave my client my deliverable, it was a handwritten report with page 2s. I do drawings, get my stencils out just like you guys do all the drawings and everything. Mm-hmm. And then they'd have a VHS tape, and they'd open up the cover, and inside would be a legend of everything on the tape and where they'd find it all. And what we'd often do at the end of a job, it was just normal for me, is you go to the lunchroom, go wherever they do the safety orientations, put it in the VCR, sit back at the table and watch it with the client, and you just kind of do. It was almost like a film review thing where you're sitting there and you're. So yeah. The other thing I always loved, and it was always make me chuckle, is you'd have a robotic pan and tilt camera head inside something like a pipe, and the camera goes left, the camera goes right, the camera goes left, the camera goes right, and you'd be doing it, and you look over your shoulder, and there'd be a bunch of hard hats going.
All the heads are doing that.
Right, left, right. So yeah.
You know what? I never actually. That's a pretty amazing. Like you'd have to do all the time stamping manually, and then watch it back, right?
Yeah. I had a printer in the early days. It was very high tech for the time, where you could run your video signal in and out of, and you'd freeze the image and hit print, and it would print out an actual, like a Polaroid type picture of whatever was on the screen. So I could print out images and then give them to the client for the report. So they could put that in. They'd have the still images right off the video. So for the time, it was very advanced. It was very impressive. You're using robotics, you're using fiber optics, video probes. You're using all these things, and it was. But you look back now, and it's like, it's so basic. But
it definitely. It is funny to think about now, and now that you can like just live stream an image to your phone.
I know,
from a drone that's couple kilometers away, but having to do that, like I remember doing corrosion surveys where we'd have to do that, and Buddy had a Ford Expedition, and in the back he had folded the seats down. He had made a custom wooden kind of little office back there where we had a printer that would print 11 by 17 and everything, and you could take your photos or like take a photo of your drawing and then print it off right there and go walk it down and or hand it to the client, and they'd be like, wow, this is amazing, right? I think that's like fairly ingenious to be honest with you, but it's funny to think that it was all done with like a VHS tape or something like that.
And years I used VHS. And then of course you went from VHS to DVD, you burned to DVD, right? We get fancy silkscreen DVDs, our logo and everything. And then that goes for a while. And then after that, it just kind of rolled, and then it started to be digital and started to be, captured in different formats. And
amazing.
It just keeps going.
So on the stack inspection, how did the camera connect to your TV or whatever you're viewing on it?
The
by
tether,
cable?
the tether from the tether from the camera.
So like 300 feet of that.
Yeah, well, the tether went from the bottom,
6.
and the aircraft cable went from the top.
Okay, so you had to go.
So I had it tethered from the bottom, so I just raised and lowered. So I only had to have.
So then you had to drop it back down and unhook it when you're done.
Yeah,
okay,
and then bring it back out. And,
I see.
Yeah,
so you needed half the cable for that.
It worked. I was blown away at how well it worked, like right out the gate, because we'd never done that before. She's like, "This is awesome." So,
While the operators are standing around going, "What the heck is this guy doing?"
But they'd never seen anything like that before too. So it looked pretty high tech. Like the whole thing was, and the centering device that I built to put it in the, because that was my part of it, was building the centering device. Phil Bedard, so he's a great lateral thinker. He's a problem solver. He does all sorts of, like, I was just blown away because he devised the thing to go up on top, and it worked great straight out the, with no, so that was pretty cool. But the centering device, I had fiberglass tent pegs that I cut on site to the right length because I estimated about how the diameter was, how it would fit. I measured up. And I used, the spring door stoppers behind doors.
Yeah. I
had those mounted to the rig that the lights were on, and they fit perfectly on the tent pegs. I remember I bought it all at Canadian Tire, and they screwed on really tight, so nothing could come loose. It all good. And as it went up and down, it would almost like jellyfish and kind of collapse and rotate, and it just worked perfectly. And I was right, and I was like, huh. That's awesome.
So that was centering the camera inside the stack.
Yeah, so it's perfectly centered inside, so nothing bounced off. Because, and stacks aren't perfectly straight or plumb, right? So they got a bit of a bow to them sometimes, a little bit this or that, a little bit of variation. Yeah. So if you just had the camera coming down, it would want to spin in circles and bounce off things. So it just stayed perfectly steady the whole time, just went up, went down, and I was like, yeah.
How did you manage the focus? Did you just rely on autofocus?
No, it's that camera had manual focus. Like, you could focus it manually on that one as well. So it was a good system. We still have that camera. I could still pull it out and use it. It's very well built. Like, it was. We maintain and look after our things. We're kind of hard on it, but we look after it. Yeah, I could still, if I wanted to pull it out, I could use that camera for work now if I needed to. So yeah.
And you could rotate it in there, or not?
It was a pan and tilt camera hit, so just a robotic camera hit. Well, like I say, that was off our first crawler, so it was one of the early rover cameras from VIT, which I think, like I say now, EnviroSight, I think is the same lineage of equipment.
So it was all, you could do anything your drone does now, really.
Well, I could,
not as convenient,
but not the easy way. Yeah, no, pretty much.
But all the same capabilities, essentially.
And same with the big spheres, right? So instead of, what we would do is we had an early explosion rated camera a pan and tilt camera with lots of flood and spotlights, and we put it on a system that would go through a top manway on it, and it had long poles to it, and I would take the pole and it would swivel over to one side, and I'd look at the camera, and then I'd start rotating it around, and I covered pretty much the entire sphere from the top with poles and controls on a robotic pan and tilt.
The pole came out the top, and you manipulated that way?
Out of the manway.
Yeah, you grab the top like a lever, and you have a lot more down below, but it's not that heavy, so you'd kind of crank it over and crank it back and forth, and and just go around, and it worked pretty slick. Used that for lots of different applications. So.
Scott, what are we doing with our lives that we're not inventing stuff like this?
I feel like I've been wasting all these years.
I know. That's pretty amazing. That's pretty neat.
That is, yeah.
I mean, now I do a lot of this myself, but I have a fellow at work I work with. He rents some space in our warehouse, and he's just a brilliant inventor of things. Every prototype of anything he makes just works immediately, and he does custom metal work and this and that. And he's a licensed mechanic by trade. But so a lot of times he and I will just sit down and scratch our heads, and the guys will say, "Well, the client wants to do this," and we're like, "I bet we can do that." And then we come up with something, and off we go. So, and sometimes it's as simple as you want to look at a firewater line, but the downcomer to it has a really weird shape in the bottom, and you can't get a push camera around it. And they're like, "Well, how do you?" And we're like, "Well, we could build something that'll go down there and get the push camera around. Why not? It's not that hard, right?" So yeah.
Crazy.
Oh, wow. That's very interesting.
Yeah.
Man. That was a good story. Wow. I didn't know you were saving that one. That was good.
Well, like I said, I think you have a fairly unique position that's fun, that allows you to play with these things. And
I've been there 25 years for a reason, right? It's
fairly creative to accommodate.
Phil's an amazing guy. Like, he started the company, the founder of the company. He's so awesome. He'll always have my back. He just gives me full autonomy, and he's just a great guy to work with. So, how do you go somewhere else? What do you do? So,
do you guys poke or encourage your employees to kind of come up with new innovations like this?
Especially the RVI guys.
Yeah.
Because sometimes you get out in the field and you have to figure something out, right? And it's good to get them used to that same sort of thought process. What can you do? What can you do safely and diligently that you're allowed to do to achieve, what you're trying to achieve on site? And it is, it's a huge part of it, is because, and that's the thing, a lot of times, especially people get into inspection with a remote system like that, and they don't want to do more than what it's just built to do, which fair enough. But the systems, like I say, aren't made to do everything. So you do have to, if you want to get the most out of it for the client, this is especially on the video inspection side, you really have to try to figure out how to get the money shot, how to get where you want to go. And the money shot isn't always where the client thinks it is. And that's one of the things about the remote visual inspection. When you're talking about troubleshooting, not the sort of stuff, for the remote or the visual inspection side, but you get the process engineering, troubleshooting, infrastructure type, plant infrastructure things. They'll say, we have this problem. We want you to go into the camera and look at it. And so you get there and you go, yeah, I don't think you have that problem. And then there's a whole lot of crickets and head scratching. And they're like, okay, now we got to go in here, 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 and here. And you're like, well. So often the scope changes on site because you don't know what you're getting into. You do have to do a little bit of MacGyvering and thinking, and
it goes from like a sniper-based approach to shotgun really quick if they don't find the results that they want.
And sometimes the MacGyvering is more about getting your equipment out than getting in, because it's kind of like I've learned. It's like having a four-wheel drive. You don't use your four-wheel drive to get into problems. You use it to get out of problems. Just a much better policy. But I remember looking in this refractory line. I don't even know what kind of weird little vessel or thing it was. And there's a tiny opening that the video probe barely fit through. But they wanted to look in a bunch of areas. And I'm like, okay. So I took an electrician's fish tape and I electrical taped it every so often to the video probe so I could manipulate it a bit and a little bit stiffer so I can turn it into a little puppetry. And, because a lot of times using video probes and such is just, you're like a puppet master. You're trying to, get this piece of spaghetti to look at the right area. And it was going great until somehow the video probe looped back on itself, because you're only looking from the end of the probe. You can't, no context. It looped back on itself and went between the fish tape and the video probe and tied itself in a knot.
Ooh.
And so you're trying to get this very expensive video probe out through a hole about the size of the video probe when it's tied in a knot. And you're like, oh man, this is Phil's not going to be very happy. Whenever I wrecked equipment, he was always super nice. Another reason why I've been there 25 years, because you're the first one never doing this stuff, and it's not always going to go perfectly. But he'd be like, don't worry about it, buds, don't worry. So I thought about it, and I had a can of WD-40. I'm like, man. So I pull it up and squirt some WD-40 through the hole, and it dissolved the glue on the tape, and the tape came apart. Hit the mic, and then I do it again. The next piece of tape. The little WD-40 tape comes apart, and it just magically came apart and just came right out. And the client's next to me looking at me, and I'm like, I do it all the time. It's all good. Yeah. My other favorite ones, I was on a site, and there was a pipe. I had the robotic crawler in it, and just a little crawler, just configured quite small. And I was going along the horizontal bit, and he wanted to look up the vertical bit, around the corner bit, see, the upper part of the elbows. I'll take a run at it. And eventually I got it up just so the tracks are just spinning out and I could see what he wanted to see. And it flipped over backwards.
Oh, no.
did a half roll, came back on his tracks and drove back out. And I'm like, woohoo.
Totally planned that.
I totally meant to do that.
I totally planned that. Yeah.
Do that all the time too.
Yeah. Well, that's part of the thing. Like even with the rigids and like, the fancy GE borescopes, like they have an articulating head, but like half the time they quit working or it'll stay stuck in a certain position, or with the rigid and or similar like products, like you have to almost like pre-bend it and then weave it in there to kind of look at what you want.
Oh yeah.
Well,
you get what you get.
Those are a skill too. Like I've been on both sides where you're trying to run it yourself. You're not very good at it, but the jobs that are nice is when there's a third party company brings their own borescopes and they operate it, and those guys are just fantastic. Like you're just watching the screen with them, tell them where you want to go, and it's almost like he's flying a drone around in there. They just poke around wherever they want and then get right back out. Like they've done that a million times before.
One of the things that I think took the most skill and was the most fun was retrievals, because people drop things in places and drop weird things in weird places. And you can have like robotic claws and various things that the manufacturers make, but whatever the situation is and the configuration of the space and the thing you're trying to pick up, it is what it is. So you get on site and you kind of scratch your head a bit and you go to the tool crib and get some, mechanics wire or this or that, or you point at the, bottle up on the shelf and, hopefully, it's like, and you clear a bottle, you empty it out, you cut it out, make a little scoop. You can see through the camera, go down, scoop something out and pull it. And they're looking at you like, I could use something fancy if you want, but I'm not going to get it out of there for you. So this works. And so, that was very, and, especially I did many, many trips doing like turbine suction tubes, because you don't want stuff going through your turbine blades. So inspecting it and then pulling different things out. And some things are hard to pull out. You can't, like if something's metal sitting on the bottom, you can't use a magnet. It's just magnets to the wall. Right. Some things you can't use a vacuum if it's lying on the bottom, because laminar flow, it won't pick it up.
Yeah.
It's very hard. You have to get on top of it somehow. So you'd always have to do a little head scratching and be like, well, how am I going to get this out of here? So
yeah, that's fun too.
And then there's the thing, you get to a point where you drive by an industrial facility, you look out the window and you start imagining all the things you can inspect and where you can put your camera, what you're doing. And that is one frustrating thing, is that you think, man, all the things that this technology could be used for, but when you've done it a long time, you have the imagination to see the capability or the potential of it. But if you get used to doing things a certain way, you just don't think of the opportunities or the potential to use it fully, right? So that's where in the past, it's often got relegated to the, reactive, the troubleshooting, we know we have a problem, or there's a place we can't put a person, you have to get to. So it was always kind of the tail being wagged by the dog. It was never at the front of the process, which is, again, when you guys were talking about putting it at the front of the process, I'm like, oh, yeah, exactly. I mean, this is a whole nother area that it should be used in, that it hasn't really been used fully the way it should be. So
yeah, make it part of plan A instead of like the plan B when you have no other choice.
And it can still be the plan B or C, because there's many different types of applications. But for your guys' world especially, it's a totally different animal. So,
well, plan B is the second drone going in to see what happened to the first one, right, Scott? So.
Yeah, that's right. Have a whole fleet of them ready.
So that's pretty good. Warren, I think this has been pretty good.
Yeah, thank you for having me on.
Is there anything anything you want to plug that Maverick can do, or Scott, is there anything else that you think we should touch on?
I don't know. This has been entertaining. I'm looking forward to listening to this one again. But
I'd be curious if we were to do this again in, say, May next year.
Yeah.
What we'd see as far as the technology, what we'd see as far as the economy, what we see as far as everything changing, like how much the changes have been happening so fast. I'm curious if we kind of did a check in a year. What's it going to look like?
That's a good idea, actually. I think that'd make for an interesting topic. See how much things have changed or haven't changed, however it goes.
Totally. Yeah.
That would be fun, and I would. Not to say I'd be amazed, but I'd be pretty impressed that we kept this going for another year.
I don't know. I think you will. It's pretty awesome.
I think amazed is a safe word to use.
I don't generally listen to podcasts. And when I saw your one about how the pandemic has changed turnarounds and such, I'm like, that seems pretty cool. I'm going to listen to that. And I listened to it. I thought it was awesome. So no, I think you guys got a good thing going. So.
Yeah, well, I think, I kind of had the idea to start this because where we're recording, my wife does one to kind of during the start of the pandemic, for her business, she wanted to keep her clients engaged in a way where she couldn't reach them in person. So I was like, look, we have all the equipment to do live streaming. Why don't we use this to do a podcast, and you can reach your audience in that way? And I was just sitting there one day and I was like, you know what? This is something that I want to do, but I don't know what to talk about towards people, especially in a podcast. And I was like, you know what? I bet we could talk about inspection. And, Scott fills a lot of the gaps in my knowledge. So I was like, Scott, I'd like to have you on a podcast with me about inspections. And he's like, you know what? That sounds like a really fun idea. And it's something we created. And as we've kind of done this, like we've realized like we kind of fill a gap where people want information, but, they want it for free, obviously. And we do provide this for free for now, but like there's $1,000 courses or, stuff like that where you don't really get to find that information or hear experience stories from people where you're not exposed to those people on site, like we were talking about. So we figured, why not just start a podcast about inspection where we can just bullshit and kind of to get it on, and experienced people like yourself can come on and share your knowledge about the technology and even fun stories and where you think the technology is going. And it provides value and a lot of entertainment to people, especially while they're sitting there working. Like it's really kind of neat to meet you, not only as someone who's listened to a couple podcasts and even interacting with people on various platforms, like social platforms that listen to the podcast. It's kind of weird. It's just, it's really neat. So we appreciate you coming on. We appreciate you listening. Anything you want to say about Maverick Inspection and how people can reach you and reach you guys for your services?
Well, the one thing I would say about Maverick is that we're kind of terrible at letting people know what we do. Honestly, we do so many things. We've been doing it for so long, and we just do it, but there comes a point where for people just to understand the the wide range of things we do in so many different industries and so diverse that if you ever wonder if we can do something, just pick up the phone and call us, because if we can't, we probably know who can.
Yeah.
And it's just one of those scenarios. We've been around a long time and have lots of contacts, and bringing people into our company with a lot of different experience and different expertise. They have lots of contacts. So it's, yeah, for sure. Just call us and let us know. Let us know what your weird and wonderful applications are. Let us know what the things you like. What's your wish list? What would you like to inspect? What would you like to do? Let us go look for technology, because it's our bread and butter. So for sure.
Well, I will say you guys are doing something right, because I did get a phone call from one of my close friends who's a resident inspector at a facility, and goes, do you know anybody else who does UAV inspections?
Yeah.
And I was like, well, have you tried Maverick? Have you tried, some of the other bigger companies? And he's like, yes, they're busy.
That's exactly
He's like,
right.
they cannot come to our site for a while. And that was actually when we first met Cortland too. And I was like, you can try Osprey, but Maverick seems to have a pretty good hold on it. And, not to, Cortland, I love you. You're still number one, even though we just met Warren, but, Osprey and, I know actually you do work with Cortland quite a bit, and it seems like you're pretty close with him, where you refer to him as Court. So
we share back and forth, and we have need some extra capacity either side. Well, we trust him to do a good job. So that's right. Well, that's the thing too, is if you subcontract or you refer someone, the last thing you want to do is refer someone or subcontract someone who's going to make you look bad. So we're always, he's at a level that we trust. So that's awesome.
He's a pro for sure, right? Yeah. So. Warren, what's the website for Maverick that people can
just
check
maverickinspection.com.
All right.
Yep.
And
it needs an update. I've been kind of over years, it's kind of become a bit of a monster, but it's accurate, but it's going to be rolled out new in the near future. So
that's the toughest part, even with the podcast. I think we haven't touched our social media or something since Remembrance Day almost.
Well, it's almost a full-time job for somebody, right? You got to have someone just running that part of it. It's really hard to try to mix that all in with everything else.
It is.
And then if you're not big enough to do that, you can't have somebody do it for you either. So that's kind of our struggle anyways with it.
Well, I think even our YouTube page is stuck on episode 6 or 7 from last season. So
gotta convince someone else to work for free with us and update that stuff.
We got to get them to pay us. So but I think maybe by the time this episode airs, I should have all the episodes uploaded to YouTube. And
it's a big commitment there.
Yeah. Well, we'll see. I got nothing but time. So, Warren, anything else you'd like to say?
Oh, thank you for having me. It's awesome. It's been a lot of fun.
I think it has been pretty fun. I think this is a great episode.
Yeah, this is a lot of fun. It really piqued my interest. A lot of things I was looking forward to talking to you with, and I can't wait to listen to it again. I think I already said that, but this is a lot of fun. Thanks for being here with us.
No, really appreciate it.
Yeah.
It's been fun going from social media to meeting you in person and getting this done.
Yeah, it still amazes me that people actually listen to it. We know that by the stats and whatnot, but when people reach out here and there with questions and comments, or yourself interested in talking with us, it's I don't even know what to think of it still, but it's quite a cool process.
Scott, it's your last chance to ask any other questions.
I think I'm good. I'm still just thinking about some of those stories you told and having some laughs to myself here. It's good. I think I'm good. You got anything else?
I think it's time for the sign off.
Is it? Is it you now?
Oh, I don't know.
I did the intro.
I don't know. All I can say is, Warren, do you have anything clever to say at the end?
Well, I think as long as man watches are still required, there will be Manwatch required, and you guys will be awesome.
I like it.
Oh, that's really good. Hit the music. Rick.
Really good, yeah. Be inventive. Warren, thanks again for coming out. I like your ingenuity. I like how you can leverage technology for your clients. And again, maverickinspections.com.
Maverickinspection.com, no S.
All right, perfect.
Yeah.
Awesome. See you guys later. Hope you guys enjoyed this episode.